The farther we move into the future, the stranger the ancient world begins to look. Modern technology can scan beneath deserts, map hidden cities through jungle canopies, and analyze microscopic traces on artifacts thousands of years old. Yet even with all of that technology, some ancient sites remain deeply difficult to explain. Not because they are myths, but because they are real. Real structures, real engineering, real civilizations that existed long before modern science and still left behind questions that science cannot fully answer. Some discoveries reveal lost knowledge. Others expose gaps in the historical record that were never expected to exist. And together, they suggest something unsettling. Humanity may know far less about its ancient past than it once believed. Far beyond the crowded temples of Luxor, hidden beneath the burning limestone cliffs west of the Nile, lies a necropolis where some colours have survived longer than entire civilizations. Inside the Valley of the Queens, paintings more than 3,000 years old still glow with the deep blues, blood reds, and gold tones so vivid they appear almost modern. Archaeologists expected faded dust. Instead, they found walls that looked freshly painted. The deeper researchers looked, the stranger the sight became. The valley was officially explored in the early 19th century by European expeditions, but systematic excavation accelerated after the work of Ernesto Schiaparelli in 1904, when the tomb of Queen Nefertari was uncovered. Buried beneath debris and sealed chambers, the tomb revealed some of the finest surviving art in ancient Egypt. What shocked researchers was not only the beauty of the paintings, but their impossible preservation. The greatest mystery of the Valley of the Queens is not gold, mummies, or curses, it is chemistry. In the tomb of Queen Nefertari, many pigments remain astonishingly vibrant after more than 30 centuries. Modern conservation teams discovered that the walls were built in multiple engineered layers: limestone bedrock, mud plaster, fine gypsum coating, mineral pigments, and an ultra-thin protective organic layer. The structure functioned almost like a sealed laboratory environment. The famous Egyptian blue pigment remains one of the oldest synthetic pigments ever created by humans. To produce it, ancient craftsmen had to heat silica, copper compounds, calcium, and alkali materials to temperatures between 850 and 1000 degrees Celsius. That level of thermal control rivals early industrial ceramic production. Even more mysterious, modern infrared imaging revealed that Egyptian blue emits luminescence under infrared light, a property unknown to science until recent centuries. Compared with Roman frescoes in Pompeii, many of which faded or deteriorated after volcanic exposure, or medieval pigments that darkened within a few hundred years, the Valley of the Queens demonstrates chemical stability that seems centuries ahead of its era. Scientists studying the tombs also discovered that the walls absorb and release moisture extremely slowly. Salt crystallization, one of the greatest enemies of ancient art, was minimized because the tombs maintained unusually stable humidity levels. Some researchers now believe the Egyptians intentionally selected certain plaster mixtures to regulate microscopic water movement inside the walls. The mystery becomes even deeper when examining restoration damage. After the tomb of Nefertari was opened to tourism in the 20th century, rising humidity from visitors immediately began degrading the paintings. Carbon dioxide, sweat moisture, and airborne fungi started damaging surfaces that had remained stable for over 3,000 years. This revealed a disturbing truth. The tombs may have originally been engineered as perfectly balanced microclimate chambers. No one fully understands how ancient Egyptian builders achieved such environmental precision without modern chemistry, climate science, or laboratory instruments. The Valley of the Queens was carved directly into unstable limestone cliffs near ancient Thebes. Geological surveys show that many sections of the rock contain natural fractures capable of causing collapses. Yet, numerous chambers survived thousands of years with minimal structural failure. Ancient engineers appear to understand stress distribution inside the mountain. Several chambers feature subtly curved ceilings that function similarly to load-dispersing vaults in later Roman and Gothic architecture. In some areas, workers intentionally left stone pillars untouched, creating primitive load-bearing support systems. The precision is difficult to explain. Many corridors maintain remarkably straight cuts over long underground distances despite supposedly being excavated with copper chisels and dolerite pounding stones. Some wall surfaces are so smooth that modern archaeologists originally assumed later restoration work had modified them. Researchers also identified narrow ventilation shafts and secondary pits that may have reduced heat buildup and dust during excavation. Mining engineers have compared these systems to early underground airflow management techniques. For a civilization working in darkness with oil lamps, primitive tools, and no modern surveying equipment, the consistency of these underground structures remains deeply puzzling. Several tomb ceilings inside the Valley of the Queens contain detailed celestial imagery representing the Egyptian afterlife. But these were not simple decorations. The stars painted across the ceilings may correspond to real astronomical cycles, particularly Sirius, whose heliacal rising mark the annual Nile flood. Some Egyptologists believe the ceilings encoded calendrical information tied to agricultural cycles and religious ceremonies. The precision of certain star arrangements has generated debate for decades. Ancient Egyptians may have observed the sky continuously over centuries to maintain long-term astronomical records. What fascinates modern lighting specialists is the visual effect inside the tombs. Under weak torchlight, the deep blue pigments absorb light differently from surrounding mineral paints, causing stars to appear unusually vivid in darkness. Some researchers compare the effect to primitive immersive environmental design. In a sealed underground chamber illuminated only by flickering firelight, the ceilings may have appeared almost alive. Unlike the popular image of obvious pyramid entrances, many tombs in the Valley of the Queens were deliberately disguised. Entrances were concealed beneath rubble, plaster coatings, and natural-looking rock debris. After only a few years of desert erosion, distinguishing a tomb entrance from the surrounding cliff became nearly impossible. Some chambers include misleading side corridors, blocked passages, and concealed niches that may have confused tomb robbers. Archaeologists also found evidence that certain tombs were reopened centuries later by Egyptian officials themselves for repairs or ritual reuse. This raises a difficult question. How did they relocate hidden entrances after the landscape had naturally changed? Several historians believe the valley functioned as a controlled security complex rather than merely a burial ground. Compared with many royal tombs that were looted within generations, some chambers in the Valley of the Queens remained hidden for extraordinarily long periods. One of the least understood mysteries is the environmental stability inside the tombs. Deep chambers experience very small temperature fluctuations compared to the outside desert, where daytime temperatures can exceed 40 degrees Celsius. The surrounding limestone acts as a massive thermal buffer, absorbing heat slowly and releasing it gradually. Modern monitoring revealed that even slight increases in visitor numbers dramatically alter humidity and carbon dioxide levels. In some areas, fungal colonies began appearing only decades after the tombs were reopened. This suggests the original environment existed in an extremely delicate equilibrium for thousands of years. Scientists now compare certain chambers to sealed archival vaults designed for long-term preservation. Yet these chambers were built over 3,000 years ago, with no electricity, no climate control systems, and no modern understanding of microbiology. The longer researchers study the valley, the more it appears that ancient Egyptian builders possessed an environmental awareness far beyond what historians once believed possible. Near the Valley of the Queens stood the workers' village of Deir el-Medina, where archaeological records revealed organised labour shifts, material management, payment systems, and strict progress tracking. This looked less like chaotic slave labour and more like a highly coordinated engineering project. Thousands of square meters of paintings, carvings, and plasterwork inside the tombs may have been completed within only a few years, requiring precise coordination between stonecutters, pigment makers, artists, and priests. Do you think the ancient Egyptian possessed engineering knowledge far beyond what modern historians currently accept? Share your thoughts in the comments below. At the border of Oxfordshire and Warwickshire in England stands a prehistoric monument older than many Egyptian pyramids. The Rollright Stones were built between roughly 3800 BCE and 2500 BCE, yet some researchers believe their positions may encode lunar and solar alignments so precise that they rival later astronomical sites across Europe. The mystery is not the size of the stones. It is the intelligence hidden in where they were placed. Unlike buried ancient cities, Rollright was never truly lost. Local legends about living stones survived for centuries before formal excavations began in the 19th and early 20th centuries. Archaeological surveys later revealed that the site was not one monument, but three separate structures built across different eras: the King's Men Stone Circle, the Whispering Knight's Chamber Tomb, and the Kingstone Monolith. Radiocarbon dating and soil analysis eventually showed that these monuments may have been constructed hundreds, possibly over 1,000 years apart, yet somehow they still appear connected by unified design. Among all the mysteries surrounding Rollright, the most controversial is the possibility that the builders intentionally transformed the natural horizon into a prehistoric astronomical instrument. The Kingsmen Stone Circle contains around 70 weathered limestone stones, arranged in an almost perfect circle approximately 31 meters in diameter. At first glance, it appears crude compared to Stonehenge. The stones are uneven, relatively small, and lack the engineered symmetry of later megalithic monuments. But modern topographic studies change that perception completely. Researchers discovered that the monument interacts with the surrounding hills and horizon lines in unusual ways. Certain viewing positions align with winter solstice sunrise, summer solstice sunset, major lunar standstill positions, and cyclical moonrise points connected to the 18.6-year lunar cycle. That last detail is where the mystery becomes extreme. Tracking the lunar standstill cycle requires decades of uninterrupted sky observation. Even advanced civilizations struggled with this. The Babylonians mathematically recorded lunar cycles thousands of years later, using written astronomy. Yet the builders of Rollright supposedly had no writing system, no metal instruments, and no known mathematical notation. Still, surveys using laser mapping and astronomical reconstruction software suggest that several sight lines around Rollright correspond closely with ancient celestial events. Some alignments deviate by only a few degrees. For comparison, Stonehenge primarily emphasizes solar alignment. Newgrange in Ireland focuses on winter solstice illumination, while Chaco Canyon in North America tracks solar and lunar cycles through horizon markers. Rollright appears to combine both terrain-based astronomy and monument geometry in a simpler but strangely effective way. What makes this even more difficult to explain is the landscape itself. Unlike Stonehenge, which sits on relatively open plains, Rollright is positioned in uneven highland terrain. The hills surrounding the monument naturally frame sections of the sky. Some archaeologists believe the builders intentionally selected this exact location because the horizon already functioned as a giant observational map. In other words, the monument may not have been built merely on the landscape. It may have been built with a landscape. This raises a disturbing possibility. Prehistoric communities in Britain may have possessed long-term observational astronomy, far more advanced than historians previously believed. The stones themselves are not enormous by megalithic standards. Most are made from local oolitic limestone and weigh between several hundred kilograms to multiple tons. The problem is the terrain. Rollright sits on elevated ground with clay-heavy soil that becomes unstable during rain. Experimental archaeology teams attempting to recreate Neolithic transport methods discovered that moving stones uphill across wet clay dramatically increases resistance. Some simulations suggest that even small stones would require dozens of workers, synchronized rope systems, timber rollers or sledges, and carefully prepared pathways. Yet no large-scale quarry roads or construction infrastructure have been found nearby. More mysterious is the stability of the stones after thousands of years. Many stones are not buried deeply, yet remain upright despite frost expansion, soil erosion, seasonal water saturation, strong upland winds and gradual ground movement. Modern engineers studying the site proposed that the builders may have intentionally positioned stones on naturally compressed subsoil or hidden limestone shelves beneath the surface. That would require an advanced understanding of ground stability without excavation machinery or geological science. At sites like Göbekli Tepe in Turkey and the Karnak alignments in France, researchers also found evidence suggesting prehistoric builders understood terrain mechanics far better than expected. Rollright may belong to the same category of forgotten engineering intelligence. A short distance from the circle stands the Whispering Knights, a collapsed Neolithic chamber tomb dating to roughly 3800 BCE. Its surviving stone chambers create unusual acoustic effects. Several independent sound experiments found that low-frequency tones resonate inside the structure more intensely than expected for such a small space. Whispered voices can also reflect unpredictably between the stones. This phenomenon appears repeatedly in ancient ritual architecture worldwide. The Hypogeum of Malta amplifies frequencies around 110 Hz. Newgrange creates echo effects within its passage. Maya temples at Chichen Itza generate engineered sound reflections, and ancient Greek theatres manipulated acoustic geometry with remarkable precision. At Rollright, the effect is weaker but still measurable. Some researchers suspect prehistoric ceremonies may have intentionally used resonance, chanting, or drumming to alter psychological states. Low-frequency sound can affect human perception, balance, and emotional response. If intentional, this would mean the builders understood practical acoustic behavior thousands of years before formal physics existed. For centuries, local folklore claimed the stones could move at night or possess supernatural energy. Modern science does not support the legends directly, but geological surveys detected subtle magnetic irregularities around portions of the site. Some theories point toward underground water movement, mineral variations in limestone, localized electromagnetic fluctuations, and buried geological fractures. Curiously, many major megalithic monuments are positioned near underground water systems or tectonic boundaries, including Stonehenge, Avebury, Karnak, and Delphi in Greece. Some geophysicists argue that ancient builders may have unknowingly sensed environmental anomalies through sound, vibration, or animal behavior. Others propose something more radical, that certain prehistoric cultures intentionally sought locations with unusual natural energy patterns. No consensus exists. Radiocarbon evidence suggests that the three main structures at Rollright were not built during the same period. The Whispering Knights may date back to around 3800 BCE, the King's Men to roughly 2500 BCE, while the Kingstone likely belongs to another phase entirely. What makes this strange is that generations separated by centuries continued building within the same landscape while preserving consistent alignments and spatial design. Despite having no writing system, maps, or architectural records, some anthropologists believe this knowledge was passed down through rituals, oral traditions, and repeated sky observation over many generations. Polynesian navigators once maintained highly complex celestial navigation systems without writing, but Rollright appears to suggest an even more advanced continuity of astronomical knowledge. After more than 4,000 years, Rollright may still be preserving a form of knowledge that modern archaeology cannot fully explain. Do you think the builders of Rollright preserved astronomical knowledge through oral tradition alone, or could they have possessed a forgotten system of recording information that has never been discovered? Share your thoughts in the comments below. Southern Malta, near the coastal town of Birzebuga, hides Ghar Dalam, a cave where extinct elephants, prehistoric humans, and Ice Age ecosystems remained sealed beneath layers of earth for tens of thousands of years. What makes this place terrifying to archaeologists is not just what was found inside, but how impossibly well everything survived. The cave became scientifically famous in the late 19th century after excavations uncovered massive fossil deposits buried beneath deep sediment layers. Researchers soon realized the cave contained one of the most important prehistoric sequences in the Mediterranean. Inside were dwarf elephant bones, pygmy hippopotamuses, ancient deer, human tools, charcoal remains, and stratified sediment layers reaching nearly 10 meters deep. The deeper archaeologists dug, the older the world became. The greatest mystery of Ghar Dalam is not the fossils themselves. It is the condition they were found in. Many of the bones discovered inside the cave remained extraordinarily intact, despite being buried for over 18,000 to 500,000 years, depending on the sediment layer. In several cases, microscopic bone structures survived with minimal fracturing, something extremely unusual in humid coastal caves. Normally, caves near marine environments suffer from salt penetration, bacterial decomposition, mineral instability, temperature fluctuations, and water erosion. Yet Ghar Dalam behaved almost like a sealed preservation chamber. Scientists studying the cave found that humidity variation inside certain chambers remained surprisingly low. Airflow patterns stayed remarkably stable, and mineral deposition occurred at unusually balanced rates. This created conditions similar to a natural climate-controlled archive. Some geological studies suggest the limestone composition of Malta may have played a major role. The cave walls contain high calcium carbonate concentrations that slowly mineralized exposed organic material before major decomposition could occur. In simple terms, the cave may have fossilized remains faster than normal Mediterranean environments. But that alone does not fully explain the mystery. Researchers compared the preservation quality at Ghar Dalam to fossil chambers inside Altamira Cave, Ice Age bone deposits from Denisova Cave, and even some sections of Lascaux Cave. Yet Ghar Dalam differs in one critical way. It is close to the sea. Marine humidity usually destroys organic preservation over long periods. Instead, this cave resisted that destruction for millennia. Some researchers propose that the cave's narrow entrance geometry may have created a naturally regulated airflow system. Measurements showed certain inner chambers maintained temperature shifts of only a few degrees throughout the year, an almost engineered level of environmental stability. Others believe underground airflow channels beneath Malta's limestone plateau may constantly remove excess moisture before fungal growth can spread. No theory fully explains how such delicate fossil layers survived repeated climate transitions after the end of the Ice Age. Because by conventional geological expectations, many of these remains should have deteriorated long ago. Among the most shocking discoveries were the remains of dwarf elephants and pygmy hippopotamuses. Some elephant species found in the cave stood barely 1 meter tall, dramatically smaller than modern African elephants, which can exceed 4 meters in height. This phenomenon is known as insular dwarfism, when large animals isolated on islands evolve into smaller forms because of limited food resources. But scientists still debate how these massive animals originally reached Malta. Today, Malta is separated from Sicily by open sea. Yet during the Ice Age, sea levels were over 120 meters lower than today. This may have exposed land bridges or shallow crossing routes across parts of the Mediterranean. Still, some migration models remain difficult to explain. Researchers estimate certain dwarf elephant ancestors weighed several tons before evolving smaller bodies. Even with lower sea levels, transporting breeding populations across unstable Ice Age terrain would have been extraordinarily difficult. This has led some archaeologists to suspect prehistoric Mediterranean migration routes were far more extensive than previously imagined. The sediment layers inside Ghar Dalam function almost like a prehistoric hard drive. Each layer records a different environmental era, including changing animal populations, humidity shifts, vegetation patterns, and human activity. What makes this unusual is how sharply separated many layers remain. In most coastal cave systems, erosion and flooding blur sediment boundaries over time. But inside Ghar Dalam, multiple layers stayed surprisingly distinct. This allowed scientists to reconstruct environmental transitions across enormous periods of time. Some sections preserve evidence of colder Ice Age ecosystems, later warming periods, and eventually human settlement. Geologists studying the cave found mineral growth patterns that appear cyclic and highly stable over long periods. Certain calcium deposits formed in extremely consistent bands, almost like tree rings. That level of environmental regularity is difficult to maintain naturally in a coastal region constantly affected by storms, rising sea levels, humidity, and tectonic activity. It suggests the cave possessed unusually stable internal airflow and drainage systems long before humans entered it. When Neolithic humans eventually occupied Malta around 5900 BCE, evidence suggests they may have deliberately used the cave's environmental stability. Excavations uncovered fire locations, placed near optimal ventilation zones, occupation areas above seasonal moisture lines, and tool concentrations in structurally safer sections of the cave. This implies prehistoric inhabitants understood airflow, flooding risks, thermal stability, and cave acoustics. Even without advanced technology, they may have mapped the cave's safest environmental zones through generations of observation. Some archaeologists compare this environmental awareness to later underground engineering seen in Derinkuyu underground city, subterranean temples like Hippogeum of Hal Saflieni, and Roman underground quarry systems. The difference is that Ghar Dalam predates most of those systems by thousands of years. Another major mystery is structural stability. Ghar Dalam exists within soft limestone near the Mediterranean coast, an environment highly vulnerable to erosion, salt damage, roof collapse, and groundwater fracturing. Yet major portions of the cave remained intact for enormous stretches of time. Modern geological surveys found that several chambers distribute mechanical stress with remarkable efficiency. Certain curved sections of the ceiling naturally redirect weight in ways similar to engineered arches. Some structural engineers noted that parts of the cave resemble optimized load distribution systems seen in later Roman and Gothic architecture. Of course, the cave was naturally formed, but the fact that prehistoric humans repeatedly occupied the safest sections suggests they may have recognized structural stability far better than expected. Perhaps the most disturbing implication of Ghar Dalam is what it suggests about the prehistoric Mediterranean itself. When the earliest animals and humans arrived in Malta, the surrounding coastline looked completely different. Huge portions of land now underwater may once have contained migration corridors, hunting grounds, freshwater systems, or entire prehistoric settlements. As sea levels rose after the Ice Age, much of that landscape disappeared beneath the Mediterranean, meaning Ghar Dalam may only be the surviving fragment of a much larger lost ecosystem. Today, marine archaeologists believe submerged prehistoric sites around Malta could still exist beneath coastal waters, buried under layers of sediment and seafloor limestone. And if those sites are ever found, they may completely change what we understand about early Mediterranean migration and prehistoric environmental engineering. Do you think Ghar Dalam was simply a rare natural phenomenon? Or could ancient humans have understood this cave's hidden environmental stability far better than we realise? Share your thoughts in the comments below. Modern Larnaca stands above the ruins of Kition, one of the most technologically advanced port cities of the ancient Mediterranean. Long before Rome dominated the seas, Kition was already processing massive quantities of copper, constructing military harbours, and building engineering systems that continue to confuse archaeologists today. The first major excavations of Kition began in the late 19th and early 20th centuries, but the most important discoveries emerged during French archaeological missions in the 1950s near Bamboula and Katari. Beneath layers of modern construction, archaeologists uncovered Phoenician temples, industrial copper workshops, military harbour installations, and enormous stone fortifications dating from roughly the 13th century BCE to the Persian era. What shocked researchers was not simply the age of the city, but the scale of its industrial activity. Slag deposits, furnace remains, and imported materials revealed that Kition was not a minor trading outpost. It may have functioned as one of the largest metallurgical and naval production centres in the eastern Mediterranean. The deeper excavations went, the stranger the engineering became. The greatest mystery surrounding Kition is its enormous copper production system. Cyprus was one of the ancient world's primary sources of copper ore. In fact, the Latin word cuprum, the origin of the English word copper, comes directly from the island's name. But Kition appears to have operated on a scale far beyond what historians once believed Bronze Age societies could sustain. Archaeologists discovered extensive furnace complexes filled with copper slag, tuyères, ash layers, and industrial debris. Scientific analysis of the slag indicates furnace temperatures may have exceeded 1,100 degrees Celsius. In some areas, temperatures may even have approached 1,200 degrees Celsius, hot enough to efficiently separate metal from sulfide ores with surprisingly high purity. That creates a major technological problem. Maintaining temperatures above 1,100 degrees Celsius consistently is extremely difficult, even for early industrial societies. Ancient furnaces fueled only by charcoal normally lose heat rapidly unless oxygen flow is carefully controlled. Yet evidence from Kition suggests sustained, repeatable high-temperature production over long periods. Some furnace structures contain underground airflow channels that resemble primitive pressure systems. Several researchers have proposed that Kition's metallurgists may have developed advanced bellows networks or natural draft engineering capable of increasing oxygen concentration inside the furnaces. If true, this would place Kition's metallurgical knowledge centuries ahead of many neighbouring civilizations. The comparison becomes even more startling when placed beside other ancient industrial centres. Early Iron Age furnaces in much of mainland Greece were generally smaller and less thermally efficient. Even some Roman furnaces centuries later used comparable airflow principles, yet Kition was already operating large-scale copper refining long before Roman industrial expansion. Another unresolved mystery is fuel consumption. Modern experimental archaeology estimates that producing a single ton of refined copper in ancient conditions could require several tons of charcoal, which in turn demanded enormous quantities of timber. Some calculations suggest ancient Cyprus may have consumed vast forest resources simply to maintain its copper economy. But there is little evidence that the island possessed enough nearby forest density to sustain industrial-scale smelting for centuries without sophisticated resource management systems. This has led to speculation that Kition maintained an organized maritime logistics network specifically designed to transport timber, ore, and finished metal across the Mediterranean. Such a system would require advanced planning, storage infrastructure, and naval coordination more commonly associated with much later empires. Even more mysterious are certain vitrified sections inside the furnace remains. Some furnace walls appear partially glassified from repeated exposure to extreme heat. Similar thermal effects have been found at a handful of ancient metallurgical sites, but the consistency of the vitrification at Kition has caused debate. Certain engineers argue that the heat control visible in the furnace chambers was unusually stable for the period. The question remains unanswered. How did an ancient Bronze and Iron Age city maintain industrial temperatures that challenged even many later societies? Near the harbour district of Bambula, excavations revealed one of the oldest known military naval installations in the Mediterranean. Stone slipways used for hauling warships onto land were constructed at carefully calculated angles. The grooves carved into the ramps allowed ships weighing several tons to be pulled from the water, while minimizing structural stress on the hulls. The precision of these gradients surprised marine engineers studying the site. If the angle was too steep, ships would crack under their own weight. Too shallow, and hauling them onto land would become nearly impossible. Yet many of Kition's slipways appear remarkably optimized. Some researchers compare the system to early dry dock engineering principles that would later become common in Hellenistic and Roman naval bases. The stonework itself creates another mystery. Certain limestone blocks contain joints so tight that even modern measuring blades struggle to fit between them. The surfaces appear unusually level despite being cut with what should have been relatively primitive bronze and iron tools. This has fueled ongoing debate about whether Phoenician engineers possessed more advanced surveying techniques than historians traditionally assume. Kition's harbour may also have functioned as a strategic naval manufacturing centre, connected to the Phoenician maritime network stretching from Cyprus to the Levant, North Africa, and possibly beyond Gibraltar. If that network operated at the scale some historians propose, Kition was not merely a port. It was an industrial machine connected to one of the largest trade systems of the ancient world. Massive defensive walls once surrounded sections of Kition. Some stones used in these fortifications weighed several tons and were transported without modern cranes, steel tools, or mechanized lifting systems. Geological analysis suggests that at least part of the material originated from quarries located significant distances from the city. This creates a logistical puzzle. Moving multi-ton blocks across uneven terrain requires coordinated labor, transport engineering, and structural planning. Yet very little direct evidence survives showing exactly how the stones were transported. Some archaeologists argue for sled systems, combined with wooden rollers and wet clay lubrication. Others believe the Phoenicians may have used maritime transport routes to move heavy blocks along the coastline before hauling them inland. Still, the cutting marks on certain stones remain controversial. Several surfaces display unusually straight incision patterns and highly uniform edges. While mainstream archaeology attributes this to long-term manual labor and abrasion techniques, some modern stonemasons have pointed out how difficult such consistency would be to achieve repeatedly using only soft metal tools. The debate continues because no definitive reconstruction has fully explained every feature observed at the site. Kition was also a religious centre closely associated with the Phoenician goddess Astarte. Excavations uncovered temple complexes whose orientations may correspond to celestial events linked to Venus. the astronomical body associated with Astarte throughout the ancient Near East. Some entrance alignments appear to match the rising position of Venus during specific seasonal cycles. If intentional, this would suggest that Kition's priesthood possessed detailed astronomical knowledge integrated into architecture and navigation. This pattern is not unique to Cyprus. Ancient Egyptian temples, Maya ceremonial complexes, and Mesopotamian ziggurats also display astronomical alignments. But Kition occupies a particularly important geographic position between these eastern and western Mediterranean cultural spheres. Some historians therefore believe cities like Kition may have helped transmit astronomical and navigational knowledge across vast maritime trade routes long before the classical Greek world reached its peak. Do you think the builders of Kition inherited lost engineering knowledge from earlier civilizations? Or were these construction techniques simply far more advanced than historians expected? Share your thoughts in the comments below. At the southern edge of Cudia Cremada, massive stone structures have survived for more than 3,000 years on an island with limited wood, limited metal, and no written record explaining how they were built. Yet some of those structures still stand with near-perfect balance, astronomical alignment, and engineering precision that many researchers struggle to fully explain. Cudia Cremada was identified during archaeological surveys of Menorca's Talaiotic culture, a Bronze and Iron Age civilization that occupied the Balearic Islands roughly between 1400 BCE and 123 BCE. Excavations uncovered cyclopean walls, ritual taller monuments, underground spaces, ceramic remains, and evidence of metallurgy. Unlike Egypt, Mesopotamia, or Greece, the Talaiotic people left almost no surviving written language. Their technology must therefore be reconstructed entirely from stone, ash, tools, and structural analysis. One of the most disturbing mysteries surrounding Cudia Cremada is the engineering logic behind its enormous stone architecture. Many walls were built using cyclopean construction, giant limestone blocks stacked without mortar. Some individual stones are estimated to weigh several tons, yet they remain fitted so tightly that modern blades cannot easily slide between them. The mystery is not merely the weight of the stones, it is the stability. Menorca experiences constant coastal erosion, seasonal humidity changes, and low-level seismic activity from the western Mediterranean basin. Over 3 millennia, those environmental pressures should have destabilized poorly engineered structures. Instead, parts of Cudia Cremada remain structurally coherent. Researchers comparing the site to Mycenaean Greece noticed a similar use of massive polygonal stonework, but the Talaiotic builders achieved this without evidence of advanced lifting cranes, iron reinforcement, or complex pulley systems. Some wall angles even appear intentionally tilted inward, distributing compressive force in ways similar to later earthquake-resistant masonry. Experimental archaeologists attempting to recreate Talaiotic transport methods discovered that moving stones across Menorca's uneven limestone terrain would require enormous manpower coordination. Yet the island's ancient population may only have numbered in the tens of thousands. This raises a difficult question. How did a relatively isolated island society organize labor and engineering with such precision? The most iconic structures at Cudia Cremada are the taulas, giant T-shaped stone monuments unique to Menorca. A vertical monolith supports a horizontal capstone weighing multiple tons. No visible mortar, no metal clamps, no carved locking mechanisms. At first glance they appear simple, but modern structural analysis suggests otherwise. Several taulas display surprisingly accurate center of mass distribution. If the upper stone were even slightly misaligned, the entire structure would collapse under uneven stress loads. Engineers studying reconstructed force models found that friction and balance alone may have been enough to stabilize these monuments, but only if the placement precision was extremely high. That creates a serious technological mystery. The Taleotic civilization supposedly lacked mathematical notation, precision instruments, or written engineering formulas. Yet the balancing tolerances of some talas suggest advanced practical knowledge of load transfer and weight distribution. Some archaeologists compare the talas to the trilithons at Stonehenge, but there is an important difference. Stonehenge used carved joints between stones. Many Menorcan talas appear to rely almost entirely on gravity and balance. In engineering terms, that is significantly riskier. Even stranger, certain talas seem positioned inside ritual enclosures where sound resonance behaves unusually. Acoustic studies conducted at several Taleotic sites suggest that low-frequency echoes become amplified within enclosed stone chambers. Researchers are still debating whether this effect was accidental or intentionally designed for ceremonies. Among all the unexplained technologies at Cudia Cremada, the most difficult mystery may be metallurgy. Archaeological excavations uncovered evidence of bronze production, high-temperature ceramic firing, slag deposits, and metalworking activity. But Menorca presents a major logistical problem. It lacks the natural industrial resources normally associated with large-scale metallurgy. Bronze production requires sustained temperatures exceeding approximately 950 degrees Celsius. Certain ceramic firing processes can demand temperatures approaching or exceeding 1000 degrees Celsius. Maintaining such heat consistently is extremely difficult even for later historical societies with abundant timber resources. Ancient Menorca did not possess large forests comparable to mainland Europe. Paleo-environmental studies suggest the island's woodland resources were relatively limited, especially after centuries of human occupation. This creates a major contradiction. How could the Taleotic people operate metalworking systems intensive enough to leave behind widespread slag and furnace remains? One theory suggests that the islanders developed highly efficient furnace architecture capable of maximizing airflow from Mediterranean coastal winds. Some reconstructed furnace experiments showed that carefully angled air channels can dramatically increase combustion temperatures without requiring massive fuel quantities. Another possibility involves charcoal optimization. Charcoal burns hotter and more efficiently than raw wood, but producing large amounts of it on a small island would risk ecological collapse. Yet archaeological evidence suggests Taleotic societies survived for centuries without obvious signs of total environmental breakdown. This implies they may have possessed sophisticated fuel management systems far beyond what historians once assumed for Bronze Age island cultures. The chemical composition of recovered slag samples also raises questions. Some metallurgical traces indicate surprisingly stable thermal conditions during smelting. Achieving that level of consistency without bellows systems comparable to later Roman designs would have been extraordinarily difficult. Comparisons with Bronze Age metallurgy in Cyprus and Sardinia reveal another anomaly. Those regions possessed richer copper networks and stronger trade infrastructure. Menorca did not, yet the Taleotic people still maintained functional metal production across generations. In practical terms, Cudia Cremada represents a civilization achieving disproportionately advanced metallurgical output despite severe environmental limitations. And no one fully understands how. Several structures at Cudia Cremada appear aligned with the solar movements and seasonal celestial events. Surveys performed at Taleotic sites across Menorca revealed orientations that correspond to sunrise positions during solstices and equinoxes. The statistical probability of multiple ceremonial structures accidentally sharing similar astronomical alignments is surprisingly low. This becomes even more mysterious because the Taleotic civilization left behind no surviving astronomical texts. There are no star maps, no calendars, and no mathematical records explaining how such alignments were calculated. Some researchers believe generations of naked-eye observations allowed the islanders to track celestial cycles with remarkable accuracy. Others argue the alignments may reflect ritual symbolism rather than scientific astronomy. Yet the precision itself remains difficult to dismiss. At certain times of year, sunlight enters parts of talaiotic ceremonial spaces at highly controlled angles, illuminating specific interior zones while leaving others in darkness. Similar solar effects appear in Newgrange in Ireland and Abu Simbel in Egypt, sites famous for intentional astronomical engineering. If the talaiotic builders independently developed comparable observational systems, then their scientific understanding may have been far more advanced than traditionally believed. Another technological puzzle involves hydrology. Menorca experiences long dry summers, limited freshwater availability, and irregular rainfall patterns. Despite this, talaiotic settlements like Cudia Cremada were positioned in ways that appear optimized for water capture and storage. Archaeologists identified sloped surfaces, drainage pathways, and terrain modifications that may have directed rainwater into collection zones. Some underground chambers may also have functioned as temperature-stable storage spaces, protecting food and water from Mediterranean heat. This suggests the talaiotic people understood local geology and seasonal environmental behavior in remarkable detail. In modern engineering language, some of these solutions resemble passive sustainability systems, technologies designed to maximize environmental efficiency without external energy sources. For a civilization with no surviving technical manuals, the sophistication is difficult to ignore. What do you think the talaiotic people truly knew about engineering and metallurgy that history has completely forgotten? Share your thoughts in the comments below. County Sligo in Western Ireland hides Carrowkeel megalithic cemetery across the Brickleave Mountains, like a forgotten machine made of stone. Built more than 5,000 years ago, the site contains passage tombs older than the pyramids of Giza. Yet what terrifies archaeologists is not its age, but the possibility that Neolithic builders understood engineering, structural balance, astronomy, and landscape geometry at a level that should not have existed in prehistoric Europe. Although local people had known about the cairns for centuries, the first major archaeological surveys only began in the early 1900s, when researchers uncovered dozens of hidden passage tombs spread across the mountain ridges. Excavations revealed cremated human remains, polished stones, bone fragments, and carefully constructed chambers sealed for thousands of years beneath enormous masses of limestone. Archaeologists expected primitive burial structures, but what they found instead looked disturbingly advanced for a civilization that supposedly lacked complex engineering knowledge. One of the greatest mysteries surrounding Carrowkeel is its location. The cemetery was constructed between roughly 3,400 and 3000 BCE on steep limestone mountains, more than 300 meters above sea level. Even today, transporting building materials across the region is difficult because of exposed rock surfaces, unstable slopes, sudden weather changes, and narrow mountain routes. Yet, Neolithic builders somehow transported and positioned stones weighing several tons without metal tools, wheeled vehicles, cranes, or known draft animals. Archaeologists estimate that some cairns contain thousands of tons of limestone, and experimental archaeology projects suggest moving a single 2-ton slab uphill using rope and log systems could require more than 150 people working in precise coordination. The mystery becomes even deeper when researchers examine the chambers themselves. Several internal stones were fitted together with surprising precision to reduce stress concentration and distribute weight more evenly, a principle comparable to later megalithic engineering seen at Newgrange and even the stonework of Sacsayhuaman in Peru. The question remains controversial among researchers. How could societies with supposedly primitive technology organize massive labor forces, transport enormous stones through dangerous terrain, and engineer stable chambers capable of surviving for more than 5 millennia? Some archaeologists believe the builders possessed advanced practical knowledge of load balancing, friction reduction, seasonal ground conditions, and coordinated force distribution. It may not have been theoretical engineering in the modern sense, but rather knowledge refined through generations of observation and experimentation. The most technically disturbing feature at Carrowkeel may be its roofing systems. Several passage tombs contain corbelled roofs, where layers of stone gradually overlap inward until the chamber closes at the top. Although the concept appears simple, structurally it is extremely dangerous because every layer transfers weight downward and inward. A small error in angle or placement can destabilize the entire chamber and eventually force the walls outward until collapse occurs. Yet many of Carrowkeel's chambers have survived for more than 5,000 years despite exposure to Atlantic storms, freezing winters, moisture expansion, seismic micro-vibrations, and continuous gravitational stress. Modern engineers studying ancient dry stone architecture note that corbelled chambers rely on extremely delicate compression physics. The inward angle of each slab determines whether forces stabilize naturally or slowly destroy the structure over centuries. What makes Carrowkeel extraordinary is that these chambers were built entirely without mortar. The stones simply hold themselves together through pressure and balance alone. Even more mysterious are the so-called roof box openings, found above the entrances of certain passage tombs. These narrow gaps allow sunlight to penetrate deep into the chambers during specific seasonal events, especially around solstices and transitional solar periods. This creates an extraordinary engineering paradox. The builders somehow had to preserve structural integrity, reduce roof pressure, prevent long-term collapse, and maintain a carefully calculated solar opening at the same time. Achieving all of this with Stone Age tools should have been incredibly difficult. Researchers comparing Carrowkeel with Newgrange discovered that both sites appear to use controlled light entry systems, but Carrowkeel's mountainous location makes the geometry even more complex because the surrounding peaks constantly alter horizon angles and solar trajectories. To align sunlight correctly, the builders may have observed seasonal solar movement for decades or even generations. Some archaeoastronomers believe the chambers were not merely tombs, but astronomical devices designed to track cyclical celestial events. Others argue the roof boxes may have served ritual functions connected to death, rebirth, or ancestor worship. However, the deeper mystery remains structural. Modern reconstructions show that alignment errors of only a few degrees could dramatically increase roof instability over time, yet many chambers remain standing after more than 5,000 years. Compared to numerous Bronze Age structures across Europe that partially collapsed after much shorter periods, Carrowkeel's survival suggests its builders understood stone compression mechanics far better than traditionally believed. Several passage tombs at Carrowkeel align with the setting sun during the summer solstice. During these brief moments, sunlight travels through narrow stone passages and illuminates the inner chambers. Similar solar alignments appear at sites such as Meeshoa, Stonehenge, and temples in ancient Egypt, but Carrowkeel differs in one important way. The cemetery exists within a mountainous horizon system, where surrounding peaks create constantly shifting observation lines that dramatically complicate solar calculations. Researchers using digital horizon modeling discovered that some cairns appear intentionally positioned to interact with specific mountain gaps, where the sun becomes visible during key seasonal periods. This suggests long-term astronomical observation and careful environmental mapping. Some calculations indicate that accurately tracking these solar cycles would require decades of repeated monitoring, implying organized knowledge transferred across multiple generations. For a society without writing, that possibility is remarkable. Another unexplained phenomenon involves sound. Researchers testing the chambers discovered unusual acoustic effects, including low-frequency resonance, amplified echoes, and standing wave vibrations. Inside certain tombs, drum beats and chanting create powerful reverberations that feel disproportionate to the actual chamber size. Similar acoustic anomalies have been documented at ancient sites in Malta and Turkey, including the underground chambers of Hal Saflieni Hypogeum. Some acoustic specialists believe these frequencies can psychologically affect human perception by producing sensations of emotional intensity, disorientation, or altered awareness. Whether these effects were intentional or accidental remains unknown. However, the repeated appearance of resonance-focused spaces across unrelated ancient cultures raises uncomfortable questions about prehistoric architectural knowledge. Did Neolithic builders understand acoustic manipulation through experimentation? Or are modern researchers simply projecting meaning onto structures built for entirely different purposes? No one knows for certain. Carrowkeel was not designed as a single tomb complex, but as an interconnected ceremonial landscape spread across multiple mountain ridges. From several cairns, observers can see precise sightlines toward valleys, lakes, and distant peaks. Satellite mapping and terrain analysis suggest some tomb placements may have been intentionally positioned to create geometric relationships across the landscape itself. This has led to controversial theories that Carrowkeel functioned as a seasonal calendar, a ceremonial pilgrimage network, or even a large-scale sacred map connected to celestial observation. Although many of these theories remain speculative, the scale of planning involved is undeniable. The cemetery stretches across several mountain summits over multiple kilometers, requiring coordinated labor, logistical planning, and long-term social stability far beyond what archaeologists once believed possible for Neolithic Europe. One of the greatest tragedies surrounding Carrowkeel is that early excavations destroyed critical evidence. In the early 1900s, some chambers were opened using blasting techniques. While archaeological recording methods were still primitive by modern standards, as a result, researchers may never fully understand how the tombs were sealed, how their construction evolved, or how their astronomical systems originally worked. Today, technologies like LiDAR, 3D modeling, DNA analysis, and ground-penetrating radar are revealing hidden details beneath untouched cairns. However, many archaeologists believe the most important clues were lost forever during the earliest excavations. Do you think the builders of Carrowkeel possessed lost engineering knowledge far beyond what history tells us? Or are we still underestimating prehistoric civilizations? Let me know your thoughts in the comments below. Mountains of western Syria hide one of the most terrifying engineering mysteries of the medieval world. Crac des Chevaliers rises above the surrounding valleys like a stone machine built to survive forever. For more than 800 years, earthquakes destroyed nearby cities, empires vanished, and armies repeatedly attacked its walls. Yet the fortress endured, not simply because it was massive, but because many of its engineering principles appear strangely advanced even by modern standards. Although local populations had known the fortress for centuries, Crac des Chevaliers entered major archaeological and military studies during the 19th century, when European explorers began documenting its scale and preservation. What researchers discovered shocked historians. This was not merely a medieval castle. It was one of the most sophisticated military structures ever constructed before the industrial era. Expanded primarily by the Knights Hospitaller during the 12th and 13th centuries, The fortress covers nearly 3 hectares and stands more than 650 meters above sea level. Historical estimates suggest thousands of masons, engineers, labourers and soldiers contributed to its construction across generations. But the deeper archaeologists examine the fortress, the stranger its engineering became. Most medieval fortifications relied on static defensive principles. Crac de Chevaliers appears to have operated differently. Its walls behaved less like rigid barriers and more like an adaptive structural system. The outer defensive walls reach nearly 3 meters in thickness, while inner sections become even heavier. Some towers exceed 9 meters thick at their bases. Yet despite their enormous mass, many surviving sections do not behave like completely rigid stone structures. Modern engineers studying the fortress observed several anomalies. Certain layers of stone appear to contain slight flexibility. Mortar composition changes between structural zones, and impact fractures often stop spreading before catastrophic collapse occurs. This is highly unusual for a 12th century fortress. In modern earthquake engineering, rigid buildings often fail because shockwaves transfer directly through continuous stone or concrete. Crac appears designed to interrupt or disperse those forces. Researchers have compared this effect to primitive seismic damping systems. The fortress also relies heavily on curved and angled surfaces instead of simple vertical walls. During medieval sieges, trebuchet projectiles weighing more than 100 kilograms could strike walls at speeds estimated between 100 and 160 kilometers per hour. Under repeated bombardment, ordinary medieval masonry should have shattered. Yet Crac survived centuries of attacks with surprisingly limited structural failure. The angle geometry may have redirected impact energy rather than absorbing it directly, a principle similar to modern blast-resistant military engineering. The disturbing question is not whether the fortress was strong. The real mystery is how medieval builders understood force distribution so effectively without modern mathematics, computer simulation, or material science. This is where Crac de Chevaliers becomes truly difficult to explain. Syria lies near several active tectonic fault systems connected to the Dead Sea Transform Fault Zone, one of the most seismically dangerous regions in the eastern Mediterranean. Throughout history, devastating earthquakes repeatedly struck the area. The earthquake of 1170 severely damaged cities across Syria, while the massive earthquake of 1202 may have killed more than 1 million people across the eastern Mediterranean, according to some historical estimates. Later, earthquakes continued affecting the region for centuries, and yet Crac survived. Not perfectly intact, but remarkably functional compared to surrounding settlements. Modern structural analysis revealed several engineering characteristics that may explain why. The fortress walls are not completely uniform. Instead of behaving as one continuous rigid mass, many sections appear compartmentalized. Internal chambers, layered stone arrangements, hidden cavities, and separated support zones may have helped disperse seismic energy before it could destroy entire structures. Some interior corridors are strangely narrow, asymmetrical, and irregular. Originally believed to be simple military passageways, newer theories suggest these spaces may have unintentionally functioned as pressure relief zones during earthquakes. Even more mysterious is the fortress mortar itself. Chemical studies of surviving materials revealed lime mixtures containing volcanic or silicate-rich compounds. In some areas, the mortar hardened similarly to hydraulic compounds used in later engineering traditions. This matters because flexibility is critical during earthquakes. If mortar becomes too brittle, stone walls crack immediately under vibration. But if mortar retains slight elasticity, structures can absorb and distribute seismic stress more effectively. Roman engineers achieved similar effects centuries earlier using pozzolana volcanic concrete in structures like the Pantheon. However, Crac's builders operated in an entirely different military environment centuries later. This raises an uncomfortable possibility. Did medieval engineers independently rediscover lost seismic construction principles? Or had fragments of Roman and Byzantine engineering knowledge survived far longer than historians believed? Some scholars argue that Crac evolved through generations of practical experimentation. Every siege and every earthquake may have taught builders how to reinforce weaknesses. Over centuries, the fortress slowly transformed into something resembling a giant engineered survival system rather than a simple castle. Modern finite element simulations conducted on certain surviving sections suggest some curved areas distribute stress more efficiently than later medieval fortifications built hundreds of years afterward. Perhaps the strangest detail of all is how certain damaged sections collapsed outward rather than inward. In most fortress failures, collapsing towers crush internal support systems and destroy core defensive areas. At Crac, some wall geometries appear to redirect structural failure away from critical zones. That implies an understanding of controlled structural sacrifice, a principle central to modern military and earthquake-resistant engineering. Western Syria experiences intense summer heat, yet many interior chambers inside Crac remain surprisingly cool even today. This effect was not accidental. The fortress incorporates vaulted ceilings, elevated ventilation shafts, narrow thermal corridors, and carefully positioned airflow channels that naturally regulate temperature. Hot air rises through upper openings, while denser cool air moves through lower passageways, creating passive circulation without mechanical assistance. Modern architects describe this as passive thermal regulation, yet Crac implemented the concept centuries before industrial ventilation systems existed. Some underground chambers maintain relatively stable temperatures because of the enormous thermal mass of limestone walls. In several storage areas, temperature fluctuations remain dramatically lower than external conditions, even after centuries of exposure. This may explain how the fortress stored food supplies during prolonged sieges. Historical accounts suggest Crac could support thousands of defenders for extended periods. That required more than military strength. It required environmental control, water management, food preservation, and thermal stability. In many ways, the fortress functioned like a giant stone refrigeration system powered entirely by physics. Viewed from above, Crac des Chevaliers reveals astonishing geometric precision. Defensive sightlines overlap with minimal blind spots, arrow slits align across multiple elevations, and curved towers maximize visibility while reducing exposed attack angles. This level of military geometry becomes even more remarkable considering the terrain itself. The fortress was constructed atop an uneven mountain ridge rather than a flat-engineered platform. Yet, despite the difficult landscape, its defensive symmetry remains highly organized. Some historians compare its strategic planning to Renaissance fortifications developed centuries later after gunpowder artillery transformed military architecture. But Crac predates many of those engineering concepts entirely. The fortress appears to anticipate future defensive principles long before the technologies that supposedly inspired them even existed. Beneath Crac des Chevaliers lies a network of tunnels, storage chambers, water systems, and hidden passageways that remains only partially explored. Many areas are still too dangerous to excavate because of collapse risks. What makes the underground system strange is that some chambers have no obvious military purpose. They're too narrow for troop movement and too isolated for ordinary storage. Some researchers believe these spaces helped regulate temperature and airflow, while others suggest they functioned as emergency survival zones during long sieges. Even today, much of the underground network beneath the fortress remains unmapped. Do you think the builders of Crac des Chevaliers truly understood advanced engineering centuries ahead of their time? Or was this fortress the result of generations of trial and error? Share your thoughts in the comments below. A windswept hill in County Donegal, Ireland, holds one of the strangest prehistoric monuments ever built. Beltany Stone Circle has stood for more than 3,000 years, with more than 60 massive stones forming a broken ring overlooking the valley below. But the deeper archaeologists studied it, the stranger it became. Some of its stones appear aligned with the movements of the sun so precisely that researchers still debate whether Bronze Age builders somehow created an astronomical observatory without advanced instruments, written mathematics, or metal surveying technology. The site was documented in the 18th and 19th centuries during surveys of Ireland's ancient monuments. Excavations later revealed charcoal deposits, burned soil, and evidence of ritual activity dating roughly between 1400 and 800 BCE. Researchers eventually realized the circle was not randomly placed. Its orientation seemed connected to solar events. The greatest mystery surrounding Beltany is not the stones themselves, it is their relationship with the sky. Several archaeoastronomers noticed that parts of the circle appear aligned with sunrise and sunset positions during the solstices and equinoxes. During the summer solstice, the sun rises in alignment with specific stones on the northeastern edge, while during winter, sunset positions appear framed through opposite gaps in the ring. Similar alignments exist at Stonehenge and Newgrange, but Beltany presents a completely different puzzle. Unlike Stonehenge, Beltany was not built with carefully cut monoliths or perfect geometric symmetry. Its stones vary dramatically in height, shape, and spacing, and some lean at unusual angles. The circle itself is slightly irregular, measuring roughly 44 to 45 meters across, rather than forming a mathematically perfect ring. That irregularity may actually be intentional. Modern researchers using horizon mapping discovered that local terrain alters where the sun visually rises and sets throughout the year. A perfectly symmetrical circle would not necessarily align correctly with celestial events when viewed from this hilltop. Some experts believe Beltany's builders intentionally distorted the geometry to compensate for the surrounding landscape, implying an astonishing level of observational astronomy. To achieve this accuracy, the builders would have needed decades of repeated sky observation, knowledge of seasonal solar movement, fixed horizon markers, and long-term tracking across generations. The sun's position shifts slowly day by day across the horizon, and detecting the exact turning points of the solstices requires patient observation over many years. Even errors of 1 or 2 degrees would destroy the alignment. Yet several stones still frame solar events with remarkable precision after 3 millennia of erosion and ground movement. Some researchers estimate that prehistoric observers may have tracked solar motion to within less than 2 degrees of accuracy, comparable to alignment tolerances found at major megalithic sites across Europe. What makes this even stranger is the environment itself. County Donegal is known for dense cloud cover, Atlantic storms, heavy rain, and foggy mornings, making it an extremely poor location for primitive sky observation. And yet, Beltany was built here anyway. One theory suggests the hilltop was chosen because of its unusually clear eastern and western horizon lines. Another proposes that the builders cared less about daily astronomical observation and more about rare ceremonial moments when sunlight aligned perfectly with the stones. But perhaps the strangest possibility is that Beltany was never intended to function as a scientific observatory in the modern sense. Instead, astronomy may have been fused with ritual, power, and psychological spectacle. During solstice sunrises, light would have entered the ring at carefully controlled angles while ritual fires burned across the hill. Witnesses standing inside the circle may have experienced an orchestrated event designed to appear supernatural. Originally, Beltany may have contained nearly 80 standing stones, though over 60 survive today. Some weigh multiple tons, creating an enormous engineering mystery. The site sits on elevated terrain with uneven ground and soft soil, yet archaeologists have never found direct evidence of roads, ramps, or transport systems connected to the construction phase. Bronze Age communities in Ireland had no cranes, no iron tools, no modern pulleys, and likely no wheeled transport capable of moving such weight uphill. Experiments using reconstructed prehistoric methods demonstrate how difficult this task would have been. Even with ropes, timber rollers, and coordinated teams, moving multi-ton stones across wet ground becomes dangerously unstable. Yet the stones at Beltany remain upright after more than 3,000 years of Atlantic weather exposure. This suggests the builders understood principles of weight distribution, soil compression, center of gravity, and long-term structural stability. Several stones were positioned with subtle inward-leaning angles that reduce collapse risk. Engineers studying megalithic structures have noted that slight inclinations can significantly improve resistance against wind and ground movement. The builders may not have possessed formal mathematics, but they clearly understood practical engineering principles through generations of experience. Some stones at Beltany contain mysterious carvings known as cup and ring marks. These symbols appear throughout prehistoric Europe, from Scotland to Iberia, yet their meaning remains completely unknown. The carvings usually consist of circular depressions, concentric rings, grooves, and connecting channels. At Beltany, several marks appear deliberately positioned on stones facing specific directions. Theories suggest they may represent star maps, ritual pathways, territorial markers, lunar calendars, or symbolic representations of water and cosmology. What unsettles researchers most is the precision of some engravings. Modern 3D scans reveal surprisingly consistent groove depth, despite the carvings being made on hard stone using primitive tools. Replicating such smooth circular forms with Bronze Age technology is extremely time-consuming. Experimental archaeologists estimate that carving a single complex cup and ring pattern could require dozens of hours using stone or early metal implements. And yet these symbols were added to stones that already demanded massive labour to transport and erect. The question remains unanswered. Why invest such extraordinary effort into markings no one today can fully decode? Another unexplained aspect of Beltany involves sound. Researchers and visitors have repeatedly reported unusual acoustic behaviour inside the circle. Voices echo strangely between stones, while strong Atlantic winds create low-resonant tones. Although not as acoustically famous as Chichen Itza, Beltany's layout may unintentionally or intentionally manipulate sound waves. Modern acoustic studies show that irregular stone spacing can create standing wave effects, directional echoes, and low-frequency resonance. During ceremonies involving drums, chanting, or fire, these effects may have dramatically amplified psychological impact. Combined with solar alignments, smoke, darkness, and seasonal rituals, Beltany may have functioned as an immersive ceremonial environment rather than a simple monument. Thousands of megalithic monuments across Europe were dismantled over centuries for construction material, yet Beltany survived largely intact. Part of the reason may have been fear. Local folklore long claimed the stones should never be disturbed. Some stories connected the circle to ancient spirits and Beltane fire rituals, and farmers avoided removing stones from the hill because they believed misfortune would follow. Ironically, superstition may have preserved what archaeology could not. What do you think Beltany Stone Circle was truly built for? An ancient observatory, a ritual site, or something we still don't understand? Share your thoughts in the comments below. Amathus stood along the southern coast of Cyprus overlooking the Mediterranean Sea. Archaeologists began systematic excavations there in the late 19th century after French expeditions uncovered massive limestone blocks, underground chambers, and inscriptions linked to one of the island's oldest kingdoms. Later excavations revealed an enormous acropolis, harbour installations, ritual caves, water systems, temples dedicated to Aphrodite, and one of the strangest stone artefacts ever discovered in the Eastern Mediterranean, a gigantic monolithic limestone vase weighing more than 14 tons. Each excavation season exposed something new. Early digs uncovered Phoenician inscriptions and defensive walls. Mid-20th century excavations revealed hidden cisterns and tunnel systems beneath the city. More recent marine archaeology projects identified submerged harbour structures and erosion-resistant foundations beneath the shoreline. But the deeper researchers dug into Amathus, the more the site stopped looking like a simple Iron Age city and started resembling an advanced engineering experiment far ahead of its time. The most famous object from Amathus is the colossal stone vase carved from a single limestone block near the summit of the Acropolis. The structure stands roughly 1.85 meters high, with walls thick enough to survive more than 2 millennia of earthquakes, humidity, and coastal erosion. The mystery is not simply its size. It is how ancient workers transported it uphill. The Acropolis rises approximately 90 meters above sea level, and the slopes surrounding it are steep and uneven. Modern engineering estimates suggest that dragging a 14-ton object up such terrain using primitive rope systems would require enormous manpower, lubrication techniques, wooden rollers, or advanced pulley systems. Yet no definitive evidence of those transport mechanisms has ever been found at Amathus. Researchers often compare the problem to the unfinished megaliths at Yangshan Quarry or the stone transport mysteries of Baalbek. However, unlike Baalbek, Amathus belonged to a smaller island kingdom with far fewer available labour resources. The vase itself raises even more questions. Its internal curvature is unusually symmetrical. Tool marks suggest controlled carving techniques rather than rough extraction. Some microscopic surface analyses indicate repeated abrasion using harder mineral compounds, possibly quartz-rich sand mixed with water. Experimental archaeologists attempting to recreate similar surfaces using Bronze Age tools found the process dramatically slower than expected. Several sections of the stone show evidence of smoothing so consistent that some researchers compare it to rotary abrasion methods used centuries later in advanced Hellenistic workshops. No one fully understands how Iron Age craftsmen on Cyprus achieved this precision. Beneath Amathus lies one of the least understood hydraulic systems in the ancient Mediterranean. Hidden below the city are underground tunnels, deep cisterns, narrow channels carved directly into bedrock, and carefully sloped water conduits designed to collect, transport, and preserve water through Cyprus's long dry seasons. This system is one of the greatest unsolved engineering mysteries at the site. Cyprus receives relatively low annual rainfall compared to regions like mainland Greece. Long drought periods would have threatened any coastal settlement, yet Amathus survived for centuries in a semi-arid environment while maintaining a large urban population. Archaeologists discovered that many channels inside the underground system were cut with extremely small gradients, sometimes only a few centimeters of drop over long distances. Even today, modern gravity-fed water systems rely on similar principles. What shocked researchers was the accuracy. Several conduits maintain slope deviations small enough to keep water flowing steadily without excessive turbulence or sediment buildup. If the angle became too steep, erosion would damage the channels. Too shallow, and water stagnation would occur. Somehow, the builders achieved a balance remarkably similar to later Roman aqueduct engineering. This has led some historians to question whether the hydraulic knowledge at Amathus developed independently, or whether ancient Mediterranean civilizations exchanged engineering concepts far earlier than previously believed. The tunnels themselves deepen the mystery. Some extend through solid limestone with surprisingly smooth walls and consistent widths. In several locations, archaeologists found ventilation shafts that may have regulated temperature and humidity inside the underground reservoirs. Thermal measurements taken in modern surveys show certain underground chambers remain significantly cooler than surface temperatures, even during intense summer heat. This suggests the system may have functioned not only as water storage, but also as a primitive climate stabilization network. Researchers often compare these features to Persian Qanat systems and underground cooling structures found in ancient Iranian desert cities. But Amathus predates many of the best-known examples. The waterproofing methods are equally puzzling. Fragments of coating material recovered from cistern walls contain lime-based compounds mixed with volcanic or marine-derived particles. Laboratory studies suggest these mixtures reduced water penetration and improved durability. Some samples show chemical behavior surprisingly similar to early hydraulic cement. This is extraordinary because advanced waterproof mortar technologies are usually associated with Roman concrete centuries later. Another unresolved question involves maintenance access. Certain tunnels are too narrow for large-scale cleaning operations, yet sediment accumulation appears lower than expected. Some researchers suspect the builders intentionally engineered water flow speeds to minimize deposits naturally, a sophisticated hydraulic concept difficult to prove but hard to ignore. Even more mysterious are reports of blocked tunnel branches leading deeper beneath the Acropolis. Ground-penetrating radar surveys detected anomalies suggesting additional buried chambers or collapsed passageways still hidden underground. Some archaeologists believe parts of the hydraulic network remain undiscovered because centuries of earthquakes buried major entrances beneath debris. If true, the known system may represent only a fraction of the original infrastructure. The harbour of Amathus presents another engineering anomaly. The southern coast of Cyprus experiences strong wave energy, salt corrosion, and seasonal storm activity. Ancient ports in such environments were usually destroyed, buried by sediment, or heavily eroded over time. Yet parts of Amathus' harbour foundations survived for more than 2,000 years. Marine archaeologists identified massive limestone blocks arranged in ways that appear designed to dissipate wave force rather than simply resist it. Some structures angle slightly against incoming currents, reducing direct impact pressure. Modern coastal engineers noticed similarities between these layouts and later Roman breakwater concepts. The harbour orientation may also have exploited natural coastal hydrodynamics. Sediment studies suggest water circulation near the harbour reduced long-term silt accumulation, allowing ships to continue operating without constant dredging. This level of environmental adaptation is difficult to explain for a relatively small Iron Age kingdom. Some submerged sections also show unusually tight stone fitting with minimal gaps. This reduced water intrusion and structural weakening caused by repeated wave compression. Comparable techniques appear in parts of Alexandria and ancient Phoenician ports, but Amathus remains one of the least studied examples. Excavations on the Acropolis show that several structures at Amathus were built in alignment with the sun during seasonal transitions. Some researchers also believe the temple complex may have been connected to the appearance cycles of Venus, the celestial body associated with Aphrodite. If true, this suggests the people of Amathus observed the sky over many generations. Experts have also noted that the precision of these alignments is similar to astronomical ritual sites in Egypt and the Levant. What makes Amathus unique is that these alignments were integrated into a functioning coastal city, combining astronomy, religion, navigation, and ancient engineering. Do you think the lost underground sections of Amathus still hide technologies or structures we haven't discovered yet? Share your thoughts in the comments below. Northern Israel's mountains hide the ruins of Montfort Castle, a fortress rising from a narrow forest ridge like the remains of a forgotten machine. Built by the Teutonic Knights in the 13th century, the castle was never supposed to survive nearly 800 years of earthquakes, humidity, war, and collapse. Yet even in ruins, Montfort still preserves engineering details that historians and architects struggle to fully explain. Unlike famous Crusader sites visible from major trade routes, Montfort remained partially hidden within dense Galilean woodland for centuries after its destruction by the Mamluks in 1271. Early European explorers documented the ruins during the 19th century, but systematic archaeological excavations only intensified during the 20th century. What researchers uncovered was unexpected. Beneath collapsed stone and vegetation lay evidence of highly advanced Gothic engineering, underground water systems, industrial metalworking, and defensive planning far beyond what most people associate with medieval frontier fortresses. One of the greatest mysteries surrounding Montfort Castle is its location itself. Most Crusader fortresses, such as Crac des Chevaliers, were built on broad, elevated plateaus with room for supply movement, livestock, and large construction operations. Montfort was different. The fortress sits on a razor-thin ridge surrounded by steep valleys and thick forest. In several areas, the slopes exceed 35 degrees. This creates a massive logistical problem. Archaeologists estimate that some limestone blocks used in the structure weighed between 500 kilograms and over 1 ton. Transporting thousands of tons of stone uphill through narrow terrain during the 1200s would have required enormous manpower and sophisticated lifting systems. Yet almost no written records describe how this was achieved. Even modern visitors struggle to reach the site on foot. Researchers have compared the problem to the transportation puzzle surrounding certain Inca structures in Peru, where heavy stones were somehow moved across impossible mountain terrain without modern machinery. In Montfort's case, however, the challenge is even stranger because the builders were operating during an active military conflict while under constant threat of attack. Some historians believe wooden cranes and pulley systems were used. Others argue the ridge itself may once have had temporary engineered ramps that later eroded away. But no definitive evidence has been found. The most technically mysterious feature of Montfort Castle is its Gothic vaulted architecture. Inside the ruins are the remains of ribbed vault ceilings built with extraordinary geometric precision. Even after centuries of collapse, the surviving arches reveal carefully calculated weight distribution systems, almost identical to those seen in major European Gothic cathedrals. That alone is astonishing. Montfort was not Paris, Cologne, or Milan. It was an isolated military fortress hidden deep in hostile territory. Yet the quality of the masonry suggests builders with elite architectural knowledge. The stones forming the arches were cut so precisely that many required only minimal mortar between joints. In Gothic architecture, this precision is critical because the stability of the vault depends on compression forces being perfectly redirected downward through the ribs and supporting columns. If even a few stones were slightly misaligned, the entire structure could fail. Modern scans of surviving vault fragments show remarkably consistent curvature and spacing. Some architectural historians argue that the measurements indicate advanced geometric planning methods rather than rough medieval improvisation. What makes this even more mysterious is the environmental stress the structure endured. Northern Israel experiences seasonal humidity changes, heat expansion, erosion, and occasional seismic activity. Yet parts of the vault system survived for nearly 8 centuries. By comparison, many medieval European castles with simpler ceilings collapsed much faster under similar conditions. Researchers have compared Montfort's vaulted halls to structures inside Notre Dame de Paris and certain Teutonic castles in Prussia. However, those structures existed in stable urban environments with access to massive labour forces and established stoneworking guilds. Montfort had none of those advantages. This raises a difficult question. How did the Teutonic Knights deploy cathedral-level engineering knowledge inside a remote war zone fortress so quickly? Some historians believe specialized architects traveled directly from Europe with the order. Others suggest the builders may have inherited architectural techniques from earlier Byzantine or Islamic engineers already familiar with advanced vault systems in the region. But the exact construction methods remain unclear. Even more intriguing are the tool marks discovered on several surviving stones. Certain cuts appear unusually straight and smooth for standard medieval chisels. While this does not imply lost technology, it strongly suggests extremely high-quality iron tools and highly trained craftsmen operating with surprising precision. To this day, the full engineering process behind Montfort's vaulted chambers is still debated. Another major mystery lies beneath the fortress itself. Montfort was built far above major freshwater sources, yet excavations revealed a sophisticated rainwater harvesting network carved directly into bedrock. Channels guided rainfall into underground cisterns designed to minimize evaporation and contamination. The engineering precision is extraordinary. Several channels maintain carefully controlled gradients over long distances, allowing water to flow steadily without damaging the stone. Some are only a few centimeters wide, yet they still function after hundreds of years. Hydraulic specialists comparing the system to Roman water infrastructure noted similarities in flow management and erosion control techniques. This is unusual because Crusader castles often relied on simpler reservoir systems. Montfort appears to have integrated far more advanced water planning, likely because prolonged sieges could otherwise make the fortress impossible to defend. Some underground sections remain inaccessible today due to collapse risks, meaning parts of the hydraulic network may still be undiscovered. Montfort's military design also appears strangely advanced for its era. Rather than relying entirely on massive outer walls, the fortress weaponized geography itself. Attackers approaching the castle were forced into narrow movement corridors where defenders positioned above could fire arrows, drop projectiles, and launch attacks from multiple angles simultaneously. Modern battlefield simulations suggest a surprisingly small defending force could hold off a much larger army within these choke points. Military historians often compare this strategy to later gunpowder-era fortification principles, where terrain manipulation became as important as wall thickness. Unlike symmetrical castles designed mainly for visibility and prestige, Montfort behaves more like a carefully optimized defensive machine. Its corridors, elevation changes, blind turns, and layered entrances create what modern military analysts would call controlled kill zones. This level of tactical environmental design was extremely rare during the Crusader period. Excavations also uncovered traces of industrial activity inside the castle complex. Researchers found slag deposits, furnace remains, and evidence of large-scale metalworking operations. Chemical analysis of some slag fragments suggests temperatures higher than those normally associated with small medieval blacksmith workshops. This has led some historians to believe Montfort functioned not only as a fortress, but also as a weapons repair and manufacturing centre for the Teutonic Order. Ventilation tunnels discovered beneath parts of the structure may have been connected to airflow systems used for furnaces. If true, this would indicate surprisingly sophisticated thermal engineering. However, much of the underground structure remains damaged or inaccessible, preventing a complete reconstruction of the system. What do you think made Montfort Castle's engineering so advanced for its time? Forgotten knowledge, elite architects, or something we still don't fully understand? Share your thoughts in the comments below. Forests of Brittany, France still hide a 4,500-year-old stone structure standing almost perfectly intact. La Roche-aux-Fées was built with more than 40 massive stones, some weighing over 40 tons, yet no mortar, no metal clamps, and no advanced machinery were ever found here. Even today, archaeologists still cannot fully explain how Neolithic builders assembled a structure this stable with such precision. The monument was first documented in detail during the 18th and 19th centuries as French antiquarians began surveying prehistoric sites across Brittany. Excavations revealed ceramic fragments and human remains dating to roughly 3000–2500 BCE, placing the structure deep within the late Neolithic period. But unlike many collapsed European dolmens, La Roche-aux-Fées remained astonishingly preserved, immediately raising questions about the engineering knowledge of its builders. What makes the site so disturbing is not simply its size. Europe contains many megalithic monuments. The real mystery is the level of structural understanding hidden inside the monument's design. The corridor stretches nearly 20 meters long and is covered by enormous capstones balanced across upright pillars. Modern structural engineers studying the site notice something unusual. The stones are not randomly stacked. Their weight appears deliberately distributed to reduce concentrated stress points. In several areas, the builders seem to have positioned heavier stones directly above naturally stronger support pillars, while lighter slabs occupy weaker sections. That kind of load management should require advanced architectural planning. Yet La Roche-aux-Fées predates Roman engineering by nearly 3 millennia. The transport of the stones remains one of the first major unsolved problems. Geological studies suggest several stones came from locations kilometers away. Moving blocks weighing 20–45 tons across muddy terrain without wheels, cranes, or iron tools would have been extraordinarily difficult. Experimental archaeology suggests that dragging a 30-ton stone across wet ground could require over 150 people working simultaneously using wooden rollers and rope systems. But there is another problem. No evidence of a nearby settlement large enough to support such a labour force has ever been found close to the monument. This has led some researchers to believe that megalithic construction in prehistoric Europe may have involved regional cooperation networks far more organised than previously assumed. Similar patterns appear at Stonehenge, where blue stones were transported over 200 kilometres, and at Carrowkeel stones, where thousands of aligned stones suggest coordinated labour on a massive scale. But the greatest mystery of La Roche-aux-Fées is hidden in what engineers call its dry lock construction system. The monument contains no mortar whatsoever, no cement, no resin, no metal reinforcement, and yet the stones remain tightly interlocked after more than 4,000 years of exposure to Brittany's wet Atlantic climate. This is where the structure becomes deeply difficult to explain. Several contact points between the stones show extremely narrow gaps, despite the surfaces not being perfectly flat. Instead of relying on smooth-cut geometry like later Greek or Roman masonry, the builders appear to have exploited natural pressure balancing. Some archaeologists believe the stones were carefully selected and rotated to create complementary weight distributions, essentially allowing gravity itself to lock the structure together. This resembles principles later seen in Incan polygonal masonry at Sacsayhuaman, where massive stones fit so tightly that even modern blades cannot easily slide between them. But the Inca achieved this nearly 4,000 years later. At La Roche-aux-Fées, the builders accomplished stability using rough megalithic slabs with no evidence of advanced cutting tools. That creates a serious technological contradiction. Modern engineers studying ancient dry stone structures note that stability without mortar requires precise management of 3 factors: weight distribution, friction coefficient between surfaces, and centre of mass alignment. If even one capstone was slightly misaligned, thousands of kilograms of downward force could eventually destabilize the corridor over centuries of erosion and seasonal ground movement. Yet the structure still stands. Laser scanning surveys have shown that several pillars lean inward at subtle angles, possibly intentionally. This may have created compressive force channels that strengthened the structure over time instead of weakening it. Similar inward force stabilization appears in Mycenaean Cyclopean walls and certain Andean stone structures, but those civilizations emerged much later. The possibility that Neolithic Europeans independently discovered primitive forms of force distribution engineering is now taken seriously by some researchers. Even stranger is the geological stability of the monument itself. Brittany's soil contains moisture-rich clay layers prone to gradual shifting. Over millennia, structures built on such terrain typically suffer uneven subsidence. Many smaller European dolmens collapse precisely because their foundations slowly destabilized. La Roche-aux-Fers somehow resisted that fate. Some engineers suspect the builders intentionally chose slightly flexible foundation zones, capable of absorbing tiny seasonal movements without fracturing the structure. Others believe the enormous weight of the monument compacted the soil over time into a more stable, load-bearing platform. But no definitive explanation exists. The astronomical alignment of the structure adds another layer to the mystery. During the winter solstice, sunlight penetrates deep into the passage at a highly specific angle. This phenomenon resembles alignments found at Newgrange, where sunlight illuminates an internal chamber during the solstice with extraordinary precision. To achieve this, Neolithic builders would have needed long-term solar observations across many years. The Earth's seasonal solar positions shift gradually along the horizon, meaning the alignment could not have been accidental. The corridor orientation suggests deliberate astronomical planning. What remains unknown is how prehistoric communities without writing systems preserved this observational knowledge across generations accurately enough to execute such projects. Some theories propose that megalithic monuments function not only as tombs, but as ceremonial calendars tied to agricultural cycles and ritual authority. Others suggest they may have served as territorial symbols, demonstrating control over labor, engineering, and sacred knowledge. Yet even those theories do not fully solve the engineering puzzle, because the monument survives in conditions that should have destroyed it long ago. The Atlantic climate of Western France produces constant humidity fluctuations, biological erosion, and repeated freeze-thaw cycles capable of cracking stone over centuries. Many medieval structures across Europe required continuous maintenance to survive these conditions. La Roche-aux-Fers had none, and still it endured. Some geologists argue that the builders intentionally selected stone types with unusually high resistance to moisture penetration and thermal stress. Others point toward the monument's layout itself. The slight gaps between some stones may actually help relieve pressure during seasonal expansion, preventing catastrophic cracking. If true, that would mean the builders understood not only weight distribution, but long-term environmental stress behavior in stone. Thousands of years before formal engineering science existed, do you think La Roche-aux-Fers was built using forgotten engineering knowledge? Or is there still something about ancient civilizations we completely misunderstand? Share your thoughts in the comments below. Ajloun Castle rises from the forested mountains of northern Jordan, nearly 1,250 meters above sea level. The fortress was first identified in medieval Islamic records connected to Saladin's campaigns, but systematic archaeological study accelerated during the 20th century after restoration teams uncovered buried chambers, collapsed tunnels, and unusual structural layers hidden beneath centuries of earthquake damage. What initially appeared to be a powerful military fortress soon became something far stranger, a medieval structure filled with engineering decisions that still confuse historians and structural experts today. Ajloun Castle was constructed in 1184 by the general Izz al-Din Usama, one of Saladin's commanders, during the wars against the Crusader states. Yet, unlike many medieval castles built rapidly during wartime, Ajloun displays a level of geometric precision and environmental adaptation that appears unusually advanced for the 12th century. Even modern military historians have noted that the fortress behaves less like a simple defensive stronghold and more like a carefully optimized surveillance and control system designed with mathematical efficiency. The first mystery begins with its location. The fortress sits on one of the highest strategic peaks in the Ajloun region, allowing visibility across major trade and military routes connecting Damascus, the Jordan Valley, and parts of Palestine. Modern terrain simulations show that the castle occupies one of the most optimal visual command points in the entire region. Researchers using GIS mapping technology discovered that signal fires lit from Ajloun could theoretically communicate with distant outposts across enormous distances using line-of-sight relay systems. This has led some historians to compare the fortress to an early medieval communication network rather than merely a castle. The precision becomes even more mysterious when considering the surveying technology available at the time. Medieval engineers lacked satellite mapping, aerial reconnaissance, or modern optical equipment. Yet the placement of Ajloun resembles the strategic calculations used in modern military radar positioning. Some archaeologists argue that Islamic engineers inherited sophisticated land measurement techniques from earlier Roman and Byzantine civilizations, but the exact methods remain poorly documented. The fortress itself contains one of the most advanced defensive systems in the medieval Middle East. Unlike many European castles of the same period, Ajloun uses layered defensive geometry. Attackers entering the structure would be forced through narrow bent corridors, elevated choke points, and angled passageways that expose them to crossfire from multiple directions simultaneously. What fascinates modern engineers is the exact angle of many arrow slits and defensive openings. Studies conducted on surviving walls showed that several openings were designed with outward widening interiors that maximized field of view while minimizing incoming projectile exposure. In ballistic simulations, some openings differ by only a few degrees from modern optimal defensive angles. This level of efficiency is rarely seen in most 12th century fortifications. Compared to many Crusader castles in the Levant, Ajloun appears unusually calculated. Historians often compare it to Crac des Chevaliers, yet even Crac des Chevaliers relied heavily on massive walls and brute defensive scale. Ajloun instead relied on controlled movement, kill zones, and tactical geometry. Another unresolved mystery involves the enormous limestone blocks used throughout the structure. Many of these stones weigh several tons and were transported onto steep mountainous terrain without modern machinery. Archaeologists still debate the transportation methods used. Some theories suggest giant earthen ramps combined with pulley systems and animal traction. Others propose temporary wooden crane structures inspired by earlier Roman lifting technologies. The problem is scale. Estimates suggest thousands of tons of material were moved uphill during construction. Even with modern equipment, transporting such loads across uneven mountain terrain would be difficult. Similar mysteries appear at sites like Masada and certain Byzantine mountain fortresses, where logistics seem disproportionately advanced for the era. But perhaps the most astonishing feature of Ajloun Castle is its resistance to earthquakes. Northern Jordan lies near tectonic fault systems connected to the Dead Sea Transform Fault Zone. Over the last 800 years, the region has experienced multiple destructive earthquakes, including major events in 1267 and 1837. Many nearby structures collapsed completely, yet large sections of Ajloun Castle survived. Modern structural analysis revealed something unexpected inside the walls. Instead of relying entirely on solid, rigid masonry, some sections contain layered internal fillings of rubble and mortar, capable of absorbing seismic vibration. Certain vaulted chambers distribute stress outward through curved low channels remarkably similar to principles used in modern earthquake-resistant construction. Researchers studying medieval Islamic engineering believe builders may have intentionally designed portions of the fortress to flex slightly during seismic activity, rather than resist movement rigidly. This concept would have been extraordinarily advanced for the 12th century. Comparisons have been made with anti-seismic techniques later seen in Ottoman and Persian architecture, yet Ajloun predates many of those developments. Some historians suspect that fragments of Roman and Byzantine engineering knowledge survived in the Islamic world and evolved into highly specialized regional construction methods, now mostly lost to history. Water management inside the fortress presents another technological puzzle. Ajloun was built on elevated terrain where permanent water access was unreliable. Despite this, the fortress maintained long-term defensive sustainability through a highly efficient rainwater harvesting system. Channels carved into rooftops and courtyards directed water into underground cisterns capable of storing enormous quantities for long sieges. Archaeologists estimate some reservoirs could preserve water supplies for months. The engineering becomes even more remarkable considering the seasonal climate fluctuations in Jordan, where summers can become intensely dry. Even more mysterious is the internal cooling effect observed inside underground chambers. Measurements taken during modern restoration projects found that some lower rooms remain dramatically cooler than the outside environment, even during extreme heat. Researchers believe the fortress used passive cooling systems based on airflow pressure differentials. Narrow ventilation shafts combined with thick stone walls created natural convection currents that continuously circulated cooler air through lower chambers. The principle resembles modern passive climate control architecture and even shares similarities with ancient Persian windcatcher systems used in desert cities centuries later. Beneath a visible structure lies another unresolved mystery: the underground passages. Ground-penetrating radar surveys have identified hidden voids and buried chambers beneath portions of the fortress floor. Some tunnels remain inaccessible due to collapse or instability. Historians debate whether these were escape routes, emergency storage areas, hidden troop corridors, or protected water systems. Several underground corridors display surprisingly smooth curvature and structural symmetry, despite being carved directly into mountain rock. Creating such stable subterranean spaces without modern drilling tools would have required immense planning and engineering skill. The fortress also reveals evidence of advanced resource management. During excavation work, archaeologists discovered remains of olive presses, food storage systems, and production facilities integrated directly into the castle complex. This suggests Ajloun was designed not merely as a defensive fortress, but as a self-sustaining military ecosystem capable of surviving prolonged isolation. Perhaps the greatest mystery surrounding Ajloun Castle is not a hidden chamber or lost tunnel, but the disappearance of the knowledge required to build it. Very few surviving records explain the mathematical calculations, construction logistics, or seismic understanding behind the fortress. Much of the engineering knowledge may have vanished during centuries of warfare, political collapse, and natural disasters across the region. Do you think Ajloun Castle was simply a medieval fortress, or evidence that ancient engineering knowledge was far more advanced than we realize today? Share your thoughts in the comments below. A massive fortress rises beside the Euphrates in northern Syria. Qal'at Ja'bar looks like a medieval stronghold, yet beneath its walls are engineering mysteries that still confuse archaeologists today. Hidden tunnels, unexplained hydraulic systems, earthquake-resistant foundations, and stonework far more precise than expected suggest the site may preserve technologies that were centuries ahead of their time. The fortress was first seriously documented by European explorers in the 19th century, but large-scale archaeological investigations accelerated during the 1960s and 1970s when the construction of the Tabqa Dam and Lake Assad threatened nearby ancient sites. excavations revealed that the visible Islamic fortress stood on older structural layers, including Byzantine and possibly even earlier foundations connected to late Mesopotamian occupation along the Euphrates trade corridor. Researchers quickly realized the site was not simply a military castle. The deeper they excavated, the stranger the engineering became. One of the biggest mysteries surrounding Qal'at Ja'bar is how such a massive structure survived for centuries on unstable terrain near one of the most unpredictable river systems in the Middle East. The Euphrates has historically shifted its banks, flooded seasonally, and eroded surrounding land. Yet parts of the fortress remained structurally stable for nearly 900 years. Archaeological surveys discovered foundation layers extending several meters below the visible walls, composed of tightly interlocked limestone and basalt blocks combined with mortar that still retain surprising hardness today. Engineers comparing the structure to other medieval fortifications found unusual similarities with seismic-resistant designs seen centuries later in Ottoman and Venetian construction. Some sections of the base appear to distribute weight outward instead of downward, reducing pressure on softer soil near the riverbank. Modern finite element simulations performed on similar medieval structures show that wider load distribution foundations can reduce localized collapse risk by over 30% during seismic stress. The strange part is that Qal'at Ja'bar appears to incorporate this principle long before formal structural mechanics existed. Even more mysterious is the fortress's relationship with water. Excavators uncovered buried drainage channels, underground conduits, and sloped stone tunnels designed to move water away from critical structural zones. Several channels maintain a remarkably consistent gradient, something difficult to achieve without advanced surveying methods. In modern hydraulic engineering, even a small slope error can cause destructive pressure buildup or stagnant flow. Yet, some of these ancient channels appear optimized with near mathematical precision. Researchers compared the hydraulic design to Roman aqueduct gradients, which often average slopes between 0.15 and 0.3% over long distances. Certain channels at Qal'at Ja'bar fall within similarly controlled ranges despite being constructed in a far more militarized environment. This has led to speculation that the builders inherited or adapted older hydraulic knowledge from Byzantine or Roman engineering traditions that once spread across the Near East. Another unexplained feature is the precision stonework found in key structural sections of the fortress. Many medieval fortresses in the region relied heavily on rough-cut stone and thick mortar. Qal'at Ja'bar, however, contains areas where the joints between stones are extraordinarily narrow. Some blocks display nearly flat contact surfaces with minimal visible gaps. The precision resembles techniques seen in Byzantine military architecture, and in some places even echoes the tightly fitted masonry found at sites like Crac des Chevaliers or certain Roman defensive structures. This creates a major logistical mystery. Transporting multi-ton stone blocks near the Euphrates would have required enormous labor coordination. Some historians believe the river itself acted as a transport highway using barges or floating platforms. Experiments involving reconstructed ancient river barges suggest that vessels operating on the Euphrates could potentially move stones weighing over 10 tons if seasonal water levels were high enough. However, there is still little direct evidence explaining how these stones were lifted and positioned with such accuracy on elevated defensive walls. Perhaps the most debated mystery lies beneath the fortress itself. Underground chambers and tunnels extend below parts of the visible structure, but many remain inaccessible because of collapse risks and political instability in the region. Early surveys described narrow corridors with unusually stable internal temperatures. Even during intense summer heat, some subterranean sections remained dramatically cooler than the surface. This has led researchers to investigate whether the tunnels were designed with passive ventilation systems. Ancient Persian wind towers and underground cooling systems such as yakhchals use pressure differences and airflow geometry to regulate temperatures naturally. Similar principles may have existed here in military form. If true, Qal'at Ja'bar may preserve one of the earliest examples of defensive climate control engineering integrated into a fortress complex. The underground structures may also have served military purposes far beyond storage. Medieval siege warfare often involved tunneling beneath enemy walls to collapse fortifications from below. Yet at Qal'at Ja'bar, some tunnels appear defensive rather than offensive. Their geometry suggests possible use for hidden troop movement, water access during sieges, or even counter-mining operations designed to detect enemy excavation attempts underground. Comparisons with Crusader fortresses reveal additional anomalies. Many Crusader castles relied on elevated terrain and thick walls alone. Qal'at Ja'bar, however, combines terrain advantage with unusually layered defensive planning. Outer walls, elevated observation points, internal supply zones, and underground access systems created multiple fallback positions. Military historians note that such integrated defensive complexity became more common in later fortification theory, yet this fortress appears to demonstrate several of those principles centuries earlier. Another unresolved puzzle concerns the chronological layers of the site. Archaeological evidence suggests repeated rebuilding phases under different powers, including Byzantine, Seljuk, and Ayyubid control. But some of the most advanced construction methods appear in lower structural layers rather than later additions. In theory, technology should improve over time. At Qal'at Ja'bar, the opposite sometimes appears true. Certain lower masonry sections are more precise than upper reconstructions. Some drainage systems embedded deep within the fortress are more sophisticated than later visible channels. This pattern resembles mysteries seen at other ancient sites where older construction techniques appear unusually advanced compared to later repairs. Similar debates surround parts of Baalbek and Sacsayhuaman, where earlier structural phases sometimes display greater engineering complexity than subsequent rebuilding efforts. The location of the fortress itself may hold another clue. Qal'at Ja'bar occupies a strategic position overlooking major movement routes along the Euphrates. From its towers, ancient observers could monitor trade, troop movement, and river traffic across vast distances. Some researchers believe the fortress functioned not only as a military base, but also as part of a larger communication network. Beacon signaling systems existed throughout the Byzantine and Islamic worlds, using fire or reflected light to transmit warnings across long distances. Under ideal conditions, chained signal towers could relay messages hundreds of kilometers within hours. Qal'at Ja'bar's elevated position and visibility across the river valley make it an ideal candidate for such a system. If connected to other fortresses, it may have operated as an early strategic communication hub, centuries before modern telecommunications. Yet despite decades of study, enormous portions of the fortress remain poorly understood. Rising waters from Lake Assad altered surrounding terrain. Political instability severely restricted archaeological work. Many buried structures were never fully excavated, and some areas may now be inaccessible forever. Ground-penetrating radar surveys suggest additional subsurface anomalies beneath the visible fortress, including possible collapsed chambers and unexplored walls hidden under layers of debris. What do you think is still hidden beneath Qal'at Ja'bar? Lost tunnels, forgotten technology, or evidence of an even older civilization? Share your theories in the comments below. Far in the countryside of Cumbria, northern England, stands Long Meg and her daughters, a prehistoric stone circle nearly 100 metres wide. At first glance, it looks like countless other megalithic ruins scattered across Britain. But hidden within its geometry is a mystery that may prove Stone Age humans understood the movement of the moon with astonishing precision thousands of years before modern astronomy existed. The monument has likely stood for more than 4,500 years, dating back to around 1500–2000 BCE. Medieval writings already mentioned the stones, but systematic archaeological surveys only began in the 18th and 19th centuries. Researchers soon realized this was not a random arrangement of rocks. The site originally contained roughly 59 to 69 stones, arranged in an enormous ring almost 330 feet across. Yet the strangest feature stood outside the circle itself. A 12-foot-tall monolith known as Long Meg, positioned separately from the others as if it served a completely different purpose. Most prehistoric communities did not possess advanced mathematics in written form, yet Long Meg displays signs of deliberate geometric planning. The stone ring is not perfectly circular. It forms a subtle, flattened ellipse aligned with the surrounding landscape. Creating a structure of that scale without aerial observation or surveying equipment would have required extraordinary spatial awareness. Modern researchers comparing Long Meg to Stonehenge discovered surprising similarities. Both sites appear to incorporate horizon-based alignments using distant hills as visual markers. At Stonehenge, the heel stone aligns with the summer solstice sunrise. At Long Meg, certain stones appear aligned with major lunar events instead. This distinction is critical. Tracking the sun is relatively simple because its annual cycle repeats every year. The moon is vastly more complicated. Its position changes constantly across an 18.6-year cycle known as the lunar standstill cycle. Predicting this pattern without writing systems or precision instruments should have been nearly impossible. Yet Long Meg may have done exactly that. Unlike the other stones, Long Meg was carved from red sandstone, while most surrounding stones are local rhyolite. That difference appears intentional. Red sandstone reflects dawn and sunset light far more intensely than darker volcanic rock. During low-angle sunlight, Long Meg glows with a deep reddish-orange hue visible across the entire monument. Researchers suspect the monolith may have functioned as a visual astronomical marker. Instead of merely being symbolic, it could have served as a fixed observation point used during specific lunar or solar events. The placement is equally strange. Long Meg stands approximately 25 meters outside the main ring, positioned in a way that creates sightlines through gaps between stones. Similar techniques later appeared in ancient observatories across the world, including the Maya complex at El Carrowkeel and the Nabatean alignments at Petra. But Long Meg predates many of those civilizations by thousands of years. On the surface of Long Meg are faint spiral carvings and ring-like symbols heavily damaged by erosion. Spiral motifs appear throughout ancient Europe, especially in Ireland's megalithic tombs such as Newgrange. Archaeologists often interpret them as solar or cosmological symbols. However, the real mystery lies in how they were carved. Microscopic studies suggest several grooves maintain relatively consistent depth and curvature. Producing such controlled patterns using primitive stone tools would have required immense skill and time. Some researchers estimate that carving even a few centimeters into dense sandstone with hammerstones could take dozens of labor hours per symbol. Yet the engravings appear deliberate rather than crude. This has led to theories that the builders possessed more advanced stoneworking techniques than traditionally assumed, possibly involving abrasive sands, water polishing, or repeated thermal cracking methods. This is the theory that transformed Long Meg from an archaeological site into one of Britain's greatest prehistoric enigmas. Several archaeoastronomers believe the monument functioned as a lunar observatory designed to track the moon's maximum rising and setting positions during the 18.6-year lunar standstill cycle. To understand how extraordinary this is, the cycle itself must be understood. The moon does not rise in the same place every night. Over nearly 2 decades, its path gradually shifts farther north and south across the horizon. At the peak of this cycle, called a major lunar standstill, the Moon reaches its most extreme positions. Modern astronomers calculate this using orbital mechanics, but prehistoric builders had no telescopes, clocks, or written mathematics. And yet, some alignments at Longmeg appear astonishingly close to these lunar extremes. Researcher Alexander Thom, famous for surveying British megalithic sites, argued that many stone circles used a standardized measurement system called the megalithic yard, approximately 0.829 meters long. Though controversial, his studies suggested some monuments encoded astronomical knowledge with remarkable consistency. At Longmeg, certain viewing angles from the monolith through specific stones align closely with lunar standstill positions observed in Cumbria's latitude. The implications are staggering. To identify the lunar cycle accurately, observers would need records spanning generations. A single human lifetime would barely cover 4 complete cycles. This means the builders may have inherited astronomical observations accumulated over centuries. Even more mysterious is the monument's landscape positioning. The surrounding hills naturally frame portions of the horizon, creating what researchers call horizon foresights. During major lunar events, the Moon appears to rise directly between certain elevated ridgelines when viewed from key positions inside the circle. This level of environmental integration resembles later observatories like the Chaco Canyon alignments in North America, where architecture and landscape were merged into a single astronomical instrument. But Longmeg may be far older. Some simulations also suggest moonlight during certain standstill events could illuminate Longmeg itself while parts of the ring remained in shadow. If intentional, the monument may have functioned almost like a giant prehistoric calendar activated only during rare celestial moments occurring once every 18.6 years. That rarity may explain why the site held such spiritual importance. A phenomenon visible only a few times within a generation would have appeared supernatural to prehistoric communities. Another mystery is how the monument survived for millennia in one of England's wettest climates. Cumbria experiences heavy rainfall, soil movement, frost expansion, and erosion. Yet many stones remain standing after more than 4,000 years. Excavations revealed some stones were stabilized using compacted rubble foundations beneath the surface. This resembles primitive load distribution techniques used in later engineering. Several stones also lean slightly inward, reducing outward pressure over time. Whether intentional or accidental remains unknown. The builders may have understood ground stability far better than archaeologists once believed. Some geologists noticed that many British stone circles, including Longmeg, are positioned near ancient fault lines or subtle magnetic anomalies. This has fueled controversial theories suggesting prehistoric people selected locations based on unusual environmental sensations, vibrations, electrical effects, or strange atmospheric conditions. While no definitive evidence proves this, electromagnetic measurements around certain megalithic sites have occasionally detected localized fluctuations stronger than surrounding terrain. Some researchers speculate ancient communities may have associated these areas with spiritual power long before understanding the science behind them. Whether coincidence or intention, the pattern continues appearing across Europe's megalithic landscape. Do you think Longmeg was simply a ritual monument, or evidence of a lost prehistoric knowledge system far more advanced than we imagine? Share your thoughts in the comments below. Beyond the famous ruins of Greece and Egypt on the Mediterranean island of Minorca in Spain, archaeologists uncovered a stone complex that should not exist at its scale. Talati de Dalt was first systematically documented during the 19th century, but major excavations in the 20th century revealed something far stranger than a simple Bronze Age settlement. Massive cyclopean walls, underground chambers, ritual courtyards, and a gigantic T-shaped stone monument known as a Torre stood at the centre of the site. Some stones weigh more than 20 tons, yet the civilization that built them lived on a relatively isolated island with limited timber, limited metal resources, and no evidence of advanced lifting machinery. Even today, engineers still debate how the Taliotic people managed to construct structures that survived over 2,500 years of erosion, humidity, salt air, and seismic movement. The first excavations uncovered remains of homes, animal bones, ash layers, pottery, and ceremonial spaces dating between roughly 1,000 and 700 BCE. But the deeper archaeologists dug, the stranger the site became. Unlike ordinary settlements, Qal'at Ja'bar appeared designed around the Torre itself. The monument consists of a vertical monolith supporting a massive horizontal slab balanced on top like a giant stone table. Similar torres exist across Menorca, but Qal'at Ja'bar became one of the most controversial because its central pillar leans noticeably to one side, while still supporting the enormous capstone above it. Modern structural simulations suggest the monument sits extremely close to its theoretical instability threshold. In most megalithic structures, ancient builders prioritized perfect vertical balance to prevent collapse. Yet here, the builders either intentionally or accidentally created a tilted load-bearing system that somehow survived thousands of years. Engineers studying stress distribution noted that the leaning pillar may actually help redirect horizontal force from Mediterranean winds and minor tremors rather than resisting them directly. This resembles flexible anti-seismic concepts found in much later architecture. Comparisons are often made to the polygonal earthquake-resistant masonry of Machu Picchu, where irregular stone joints absorb seismic energy instead of cracking under rigid pressure. The mystery becomes even greater when researchers examine the stone itself. The limestone blocks used at Qal'at Ja'bar were extracted, transported, and positioned with extraordinary precision despite the apparent lack of advanced metallurgy. Bronze Age copper tools were relatively soft compared to the stone being shaped. Experimental archaeologists attempted to recreate similar cuts using period-accurate tools and discovered the process would require enormous labour coordination and long-term planning. Some stones appear fitted so tightly that even modern blades struggle to slide between them. Similar unexplained precision exists at Mycenaean sites in Greece and at certain Andean structures in Peru, despite no known cultural connection between these civilizations. Transporting the stones may have been even harder than shaping them. Menorca lacks the massive forests needed for large-scale wooden roller systems, comparable to those theorized for Egyptian pyramid construction. Researchers estimate some blocks would have required coordinated teams of over 100 people moving in perfect synchronization across uneven terrain. Yet the Taliotic civilization was relatively small in population. This raises an unsettling question. Did these island communities possess engineering knowledge far beyond what historians normally attribute to Bronze Age Mediterranean societies? Another major mystery lies beneath the settlement itself. Excavations uncovered underground chambers and narrow stone corridors with unusually stable internal temperatures. Measurements taken during summer months showed some chambers remaining several degrees cooler than the outside environment, even during intense Mediterranean heat. This has led researchers to compare the system with the passive cooling techniques of ancient Persian yakhchals, or the ventilation networks inside Derinkuyu underground city. Some archaeologists believe these underground spaces stored grain or preserved ritual offerings. Others suspect they served ceremonial purposes connected to ancestor worship or astronomical observation. The astronomical theory surrounding Qal'at Ja'bar is one of the most debated aspects of the site. Several researchers proposed that the Torre and surrounding structures align with celestial events involving stars from the Centaurus constellation. Today, those stars are barely visible from Menorca because of Earth's axial precession, but during the late Bronze Age they would have appeared slightly higher above the horizon. If the alignment theory is correct, the builders may have tracked long-term stellar movement across generations. That level of observational continuity would place them closer to advanced astronomical cultures than isolated island tribes. The Torre itself may also have functioned as an acoustic device. Sound experiments conducted around the monument revealed unusual low-frequency resonance patterns created by reflected echoes between the standing stones. Similar acoustic phenomena have been documented inside Hal Saflieni Hypogeum, where certain tones amplify dramatically within underground chambers. Researchers discovered that rhythmic chanting near the Torre creates vibrations that seem to concentrate toward the central monument. Some theorists argue ancient ritual specialists intentionally designed the space to manipulate sound and psychological perception during ceremonies. Evidence of fire rituals strengthens that possibility. Ash deposits and burned animal remains were found concentrated around ceremonial sectors rather than ordinary residential areas. Yet there is little evidence of large-scale cooking or industrial activity nearby. This suggests the fires may have been symbolic rather than practical. The repeated use of ritual burning over centuries indicates the Torre was not merely decorative architecture, but likely the spiritual centre of the settlement. One of the strangest aspects of Qal'at Ja'bar is how isolated its engineering traditions appear. The Taliotic culture developed unique architectural systems unlike those of mainland Iberia. Circular stone houses, monumental towers called taliots, and Taula sanctuaries have few direct parallels elsewhere in Europe. Yet some structural concepts resemble techniques seen thousands of kilometers away. Polygonal anti-seismic masonry, astronomical alignments, passive climate control, and acoustic ritual chambers all appear independently at advanced ancient sites across the world. Whether this represents coincidence, convergent engineering, or lost exchanges of knowledge remains unknown. Archaeologists also struggle to explain why the civilization declined. Around the late 1st millennium BCE, Taliotic society began transforming under external Mediterranean influence, especially from Carthaginian and later Roman expansion. Some ceremonial sites were abandoned, others were modified beyond recognition. But the knowledge required to build the original taulas appears to have vanished. No surviving texts describe how the monuments were constructed. No tools capable of lifting the largest stones have ever been found. The engineering methods disappeared almost as suddenly as they appeared. Even modern reconstruction attempts remain incomplete. In controlled experiments, archaeologists using Bronze Age technology successfully moved smaller stones, but recreating the precise balancing of Qal'at Ja'bar's leaning taula proved extraordinarily difficult. Maintaining stability while lifting a multi-ton horizontal slab onto a tilted vertical support without catastrophic collapse requires precise force distribution and timing. Ancient builders somehow solved this problem over 2 millennia ago. Do you think the builders of Qal'at Ja'bar possessed engineering knowledge far beyond what modern historians believe? Share your theory in the comments below. Buried beneath centuries of vegetation and collapsed stone in the Gulf of Morbihan off the coast of Brittany, France, Gavrinis cairn was rediscovered in 1835. The monument was initially believed to be just another Neolithic burial mound, but when archaeologists entered the narrow passageway, they uncovered something almost impossible for its era, one of the most heavily engraved megalithic interiors ever discovered on Earth. The cairn dates to roughly 3,500 to 3,000 BCE, making it older than Stonehenge and nearly contemporary with the earliest Egyptian pyramids. The structure consists of a 14-metre-long passage leading into a central chamber beneath a massive mound nearly 50 metres wide. Yet the true mystery was never its size. It was the extraordinary precision hidden within the stone itself. More than 60% of the stones lining the passage are carved with dense geometric symbols, spirals, wave patterns, axes, arcs, and abstract shapes. Some engravings cut several millimetres deep into hard granite with astonishing consistency. This is where the mystery begins. The people who built Gavrinis supposedly lived in the late Stone Age, before advanced metallurgy became widespread in Western Europe. Their tools were primarily stone, bone, and primitive wood implements. Yet many carvings appear so clean and controlled that some researchers compare them to marks created with metal chisels. Experimental archaeologists have attempted to recreate similar engravings using replica Neolithic tools. The results show how extremely labour-intensive the process would have been. Creating only a small section of Gavrinis-style carving can require dozens of hours of continuous hammering and polishing. The entire monument contains thousands of engraved lines. The amount of labour alone suggests an organised society with specialised craftsmen, long-term planning, and technical knowledge far beyond what is traditionally associated with Neolithic Europe. Even more mysterious is the symbolic consistency. Similar patterns appear across Ireland, Wales, and other Atlantic megalithic sites. This has led some scholars to believe that a sophisticated maritime culture may have connected distant communities thousands of years before recorded history. One of the greatest engineering mysteries of Gavrinis is the transport of its stone blocks. Several granite slabs used in the structure weigh between 10 and 20 tons, yet the island itself contains no natural source for many of these materials. The builders had to quarry the stones from the mainland, move them across open water, then drag them uphill onto the island, all without iron tools, modern cranes, or wheeled vehicles. Researchers have proposed wooden sledges, log rollers, rope systems, tidal transport, and giant rafts. However, none of these explanations fully solve the logistical problem. Even modern experiments moving stones weighing only a few tons require coordinated teams and carefully engineered support systems. Comparisons are often made with Stonehenge, where some bluestones travelled over 200 kilometres, and with the Egyptian pyramids, where limestone blocks weighing several tons were transported across the Nile. But Gavrinis adds another challenge: sea transport in unstable Atlantic waters nearly 5,000 years ago. The precision of placement is equally astonishing. Many stones fit together tightly enough to survive thousands of years of moisture, shifting earth, and coastal erosion. Brittany experiences strong Atlantic humidity and seasonal weathering, yet the internal chamber remains structurally stable. The engravings inside Gavrinis may represent far more than decoration. Some archaeologists believe the symbols form a ritual language or a prehistoric communication system. Repeating motifs appear in deliberate arrangements rather than random artistic placement. Certain curved patterns resemble flowing water or sound waves, while others resemble celestial cycles. One recurring image resembles an axe or plough, another resembles serpentine movement or tidal motion. Some researchers interpret the carvings as symbolic representations of cosmology, fertility, seasonal cycles, or navigation. The problem is that no written records exist from this culture. Without texts, historians can only compare the carvings statistically with symbols found at other megalithic sites. Remarkably, several patterns closely resemble motifs from Newgrange in Ireland and passage tombs across Atlantic Europe. This suggests the existence of a large cultural network capable of sharing architectural and symbolic traditions across hundreds of kilometres. For a civilization officially classified as primitive, the scale of coordination appears unexpectedly advanced. One of the most shocking discoveries at Gavrinis came from the ceiling slab above the burial chamber. Researchers realized the engraved patterns on this stone continued onto fragments located at entirely different sites across Brittany. When digitally reconstructed, the fragments appear to have once formed a single enormous standing stone, possibly over 14 meters tall. At some point in prehistory, the giant monolith was deliberately broken apart and reused in multiple monuments. This discovery changed how archaeologists viewed Gavrinis entirely. Instead of being an isolated structure, Gavrinis may have been built from the ruins of an even older ceremonial complex now lost to time. Some scholars compare this to the recycling of sacred stone seen in ancient Egypt or Rome, where older monuments were dismantled and incorporated into newer structures. But why destroy such a massive stone in the first place? No definitive answer exists. Possible explanations include religious transformation, political conflict, environmental disaster, or ritual destruction connected to changing beliefs. The narrow stone corridor inside Gavrinis creates unusually powerful acoustic resonance. Modern sound experiments demonstrate that low-frequency voices and rhythmic impacts echo intensely through the chamber. Certain tones produce standing wave effects that amplify vibration throughout the passage. This phenomenon is not unique to Gavrinis. Similar acoustic anomalies appear in Newgrange in Ireland and the Hypogeum of Malta. In all three cases, researchers suspect ancient builders intentionally designed spaces to manipulate sound during rituals. Neuroscientists studying resonance in enclosed spaces have noted that repetitive low-frequency sound can alter human perception and emotional response. Some frequencies may even induce trance-like states. If this interpretation is correct, Gavrinis was not merely a tomb. It may have functioned as a ritual machine, a structure engineered to combine darkness, echo, vibration and symbolic imagery into an overwhelming psychological experience. Despite being over 5,000 years old, Gavrinis remains remarkably stable. The mound above the chamber weighs thousands of tons, yet the internal passage has resisted collapse for millennia. Engineers studying the site discovered that weight distribution is carefully transferred through upright support stones and horizontal capstones. The builders appear to have understood structural load balancing long before formal mathematics or architectural theory existed. This sophistication is often compared to corbelled chambers, Newgrange, or even later Mycenaean tombs in Greece. However, Gavrinis predates many of these examples by centuries. The monument also survives in a harsh coastal environment exposed to Atlantic moisture and salt air. This durability suggests the builders possessed practical geological knowledge about stone selection and placement. Several researchers believe Gavrinis was connected to astronomical observation. At certain times of year, sunlight appears to penetrate the entrance passage at precise angles. Although the alignment is less dramatic than the winter solstice illumination at Newgrange, the orientation still suggests intentional solar positioning. Ancient societies across Europe often linked burial monuments with celestial cycles. Seasonal sunlight could symbolize death, rebirth, agricultural renewal, or cosmic order. The precision required for these alignments is remarkable. Even a small angular error during construction would alter how light entered the chamber over centuries. This raises a difficult question. How did a supposedly prehistoric society achieve such spatial accuracy without advanced instruments? What do you think Gavrinis truly was? A ceremonial tomb, an ancient knowledge center, or evidence of a lost civilization far more advanced than we imagine? Share your theories in the comments below. Montreal Castle rises above southern Jordan on a lonely mountain nearly 1,300 meters above sea level, around 30 kilometers north of Petra. Today the fortress is often called Cudia Castle, but during the Crusader period it was known as Montreal, meaning Royal Mountain. It was constructed in 1115 CE by King Baldwin IV of Jerusalem to control trade routes moving between Arabia, Egypt, and the Levant. Archaeologists first began documenting the site systematically during the 19th century, but major excavations accelerated in the 20th and 21st centuries after researchers discovered that the visible ruins represented only a fraction of the fortress. Beneath the castle were hidden tunnels, giant cisterns, underground chambers, and engineering systems carved directly into the mountain itself. What shocked researchers was not simply the size of the fortress, but the sophistication of the survival technologies embedded inside it. In one of the driest regions of Jordan, medieval builders created a self-sustaining stronghold capable of surviving long sieges with minimal outside support. Even today, parts of the hydraulic system still function after almost 900 years. The greatest mystery surrounding Montreal Castle is water. The fortress stands in an environment where annual rainfall averages only around 150-200 millimeters. In such conditions, sustaining hundreds of soldiers, animals, and civilians should have been nearly impossible. Yet excavations revealed a massive network of water reservoirs carved deep into the limestone beneath the fortress. Some cisterns reached several meters in depth and were coated with waterproof lime mortar that still resists leakage centuries later. Engineers studying the plaster found unusually dense mineral compositions similar to hydraulic mortars, later seen in advanced Islamic and Roman structures. The material reduced water seepage despite constant pressure and temperature fluctuations. Researchers estimate the storage system may have held hundreds of thousands of liters of water, enough to sustain a garrison through months of siege. The scale rivals hydraulic systems found in Nabateh and Petra, despite Montreal being a military fortress rather than a trade city. The mystery becomes deeper when considering construction logistics. Every chamber had to be carved manually into hard rock at high altitude. Ventilation, drainage, and overflow control were all integrated into the design, while some channels were angled with such precision that water continued flowing efficiently despite centuries of erosion. Modern hydrologists have compared Montreal's water management to later medieval castles in Europe, yet many European fortresses built centuries afterward possessed far less efficient systems. In some ways, Montreal appears technologically ahead of its time. One of the most terrifying discoveries at Montreal Castle is the underground stairway descending deep beneath the mountain. The passage contains nearly 300 narrow stone steps cut directly into bedrock. The tunnel drops toward a hidden water source outside the main fortress walls, allowing defenders to retrieve water during siege conditions without exposing themselves to enemy attacks. The engineering difficulty of this structure is extraordinary. Archaeologists note that the staircase maintains a remarkably stable angle for long distances. Several sections include air shafts for ventilation, water runoff channels were cut into the floor, and structural niches appear to reduce collapse pressure. Creating such a tunnel with 12th century tools would have required enormous labor and precise planning. The deeper sections become extremely narrow, suggesting builders understood how to reduce stress fractures inside confined rock corridors. Some researchers compare the system to subterranean works at Petra or Derinkuyu underground city in Cappadocia. However, Montreal differs because its tunnels were integrated into an active military fortress perched on a steep mountain ridge. Even stranger, some portions of the tunnel appear older than the Crusader occupation itself. Tool marks and masonry styles differ between sections, leading to speculation that earlier Nabatean or Byzantine builders may have created the original passage centuries before the Crusaders arrived. Jordan lies near tectonically active fault systems connected to the Dead Sea Transform. Over the centuries, the region experienced multiple destructive earthquakes strong enough to destroy entire cities. Yet major portions of Montreal Castle still stand. Structural surveys revealed several advanced construction techniques, including alternating large and small stone blocks to absorb vibration, flexible inner wall cores packed with rubble, foundations anchored directly into natural bedrock, and curved wall sections distributing lateral force. These methods resemble anti-seismic techniques later documented in Byzantine and even Incan architecture. Instead of relying purely on rigid mass, the builders created walls capable of dissipating energy during tremors. Scientists studying ancient seismic engineering often compare such systems to Machu Picchu or Roman fortifications in Syria. But Montreal's remote desert location makes its sophistication difficult to explain. The fortress was supposedly built rapidly for military necessity, yet parts of its structural planning appear highly specialized. Some walls also show evidence of repeated repairs using different masonry traditions, suggesting the castle evolved over centuries and possibly incorporated knowledge from Crusader, Arab, Byzantine, and local Levantine builders simultaneously. Several stone blocks within Montreal display unusually smooth cuts and tightly fitted joints. Certain surfaces appear polished beyond what historians would expect from a frontier military fortress built under harsh conditions. Archaeologists documented nearly straight incision lines, symmetrical block shaping, narrow mortar gaps, and precision-fitted corners resistant to shifting. The mystery is not that medieval builders could cut stone, but that they achieved such consistency in an isolated desert fortress with limited transport infrastructure. Some theories suggest prefabricated blocks were shaped elsewhere and transported uphill. However, hauling multi-ton limestone blocks onto a steep mountain ridge would have required massive manpower and advanced logistical coordination. Others believe the Crusaders reused older Nabatean or Roman stone foundations already present on the site. This would explain why certain sections appear far more refined than neighbouring walls. Geological analysis also found differences in weathering rates between stones, implying some materials may originate from different construction periods entirely. In 1187, after the Battle of Hattin, the armies of Saladin swept across the Crusader kingdom of Jerusalem. Most strongholds collapsed relatively quickly. Montreal did not. Historical chronicles describe a prolonged siege lasting more than a year before the fortress finally surrendered in 1189. For a remote castle isolated in the desert, such endurance is astonishing. The defenders reportedly survived despite extreme shortages and encirclement. Medieval sources even describe soldiers selling possessions for food as the siege dragged on, yet the fortress continued resisting long after many larger Crusader strongholds had fallen. Military historians believe Montreal's survival depended on hidden water reserves, underground storage chambers, passive cooling systems inside the rock, and carefully rationed internal resources. The underground architecture likely stabilized temperatures naturally. Rock-cut chambers remain significantly cooler than the outside desert heat even today, preserving water and food far longer than surface storage alone. Some unexplored underground sections remain inaccessible because of collapse danger, meaning the fortress may still conceal undiscovered chambers or tunnels. Many archaeologists believe the visible ruins represent only part of the original complex. Satellite surveys and excavation data indicate that large sections of the upper fortress disappeared over time due to earthquakes, stone reuse, and erosion. Ancient descriptions portray Montreal as far larger than what survives today. Researchers suspect the castle once included elevated towers now destroyed, multi-level defensive terraces, additional cistern systems, and hidden communication corridors. Ground-penetrating radar detected anomalies beneath collapsed sections, suggesting buried chambers still remain unexplored. the possibility that entire portions of the fortress remain underground has fueled speculation for decades. Some historians even theorize Montreal functioned as both a military fortress and a protected treasury station controlling caravan wealth moving through the region. Do you think Montreal Castle was simply a crusader fortress? Or could it have been built upon the lost engineering knowledge of far older civilizations? Share your theories and thoughts in the comments below. Cauria megaliths lies in southern Corsica near Sartène, one of the most rugged regions in the Mediterranean. Archaeologists first began documenting the site seriously during the 19th century, but large excavations accelerated in the 1960s and 1970s when researchers uncovered aligned menhirs, burial structures, fortified settlements, and evidence of Bronze Age conflict. The complex mainly includes the alignments of Stantory and Rinagdu, where dozens of standing stones still dominate the landscape after more than 3,000 years. What immediately shocked archaeologists was the scale of engineering on a mountainous island society supposedly limited to primitive Bronze Age tools. Some stones exceed 3 meters in height and weigh several tons. Unlike Egypt or Mesopotamia, Corsica had no major river transport systems, no evidence of advanced wheeled infrastructure, and relatively small populations during the Bronze Age. Yet the stones were quarried, transported, carved, aligned, and stabilized with remarkable precision. The more scientists studied Cauria, the more the site began resembling a forgotten technological experiment hidden inside prehistoric Europe. One of the greatest mysteries surrounding Cauria is how its builders moved enormous granite monoliths across uneven mountainous terrain. Granite is among the hardest natural stones, with quartz-rich compositions measuring roughly 6-7 on the Mohs hardness scale. Several of the stones likely weighed between 5 and 15 tons. Modern archaeological experiments suggest that moving a 10-ton granite block over rough terrain using primitive rollers and ropes would require at least 150-200 people under controlled conditions. But Bronze Age Corsica may not even have supported large concentrated populations capable of sustaining such labour forces continuously. This creates a paradox similar to the transportation mysteries seen at Stonehenge and Göbekli Tepe. In all three cases, ancient societies appear to possess organisational capabilities far beyond what historians traditionally assigned to them. Even more puzzling is the absence of clear transport scars. Archaeologists have found very limited evidence of prepared stone roads, ramps, or large-scale infrastructure around Cauria. Some researchers believe seasonal mud lubrication or wooden sled systems may have been used, while others suspect transport occurred during wetter climatic phases when the terrain behaved differently. None of these theories fully explain the efficiency required to erect multiple monuments across the region. Corsica sits within a tectonically active Mediterranean zone influenced by movements between the African and Eurasian plates. Despite this, many of the menhirs at Cauria have remained upright for over 3 millennia. Geological surveys revealed something extraordinary. Many stones were buried deep into the ground, often around 1/3 of their total height. This ratio closely resembles modern counterweight stabilization principles, used in engineering to resist lateral motion and vibration. The builders appear to have understood load distribution, center of gravity, and soil pressure with surprising sophistication. Some foundation pits also contain compacted gravel and smaller stabilizing stones functioning almost like primitive seismic dampeners. This has led some engineers to compare Cauria's construction logic with earthquake-resistant techniques later seen in Inca architecture at Machu Picchu, where stone structures survived major seismic activity for centuries due to careful weight balancing and interlocking geometry. For a Bronze Age island society, such structural understanding remains difficult to explain. The carvings at Cauria may be the site's most disturbing technological anomaly. Several menhirs depict human faces, weapons, chest armour and long swords engraved directly into granite surfaces. Some grooves remain surprisingly symmetrical and deep despite thousands of years of erosion. Experimental archaeologists attempting to replicate similar carvings using Bronze Age copper tools discovered the process was extremely slow and destructive to the tools themselves. Certain lines appear polished beyond what crude Hammerstone methods should realistically achieve. Under close inspection, some surfaces show abrasion patterns that resemble repeated grinding using harder mineral compounds, possibly quartz sand mixed with water. This has triggered comparisons with other unexplained stoneworking mysteries around the ancient world, including the ultra-precise granite drilling marks inside Great Pyramid of Giza and the finely cut basalt blocks at Sacsayhuaman. Researchers still debate whether Cauria's builders developed unusually advanced local stoneworking techniques or inherited knowledge through Mediterranean trade networks. Many Cauria statues portray armed warriors carrying long blades and defensive gear. This is highly controversial because some carvings may predate the widespread appearance of comparable weapon systems in Corsica itself. The statues imply either rapid technological diffusion or direct contact with more advanced maritime cultures. Some archaeologists point towards similarities between Corsican menhirs and the Nuragic warrior statues of Sardinia, located hundreds of kilometers away across the sea. This raises major historical questions. Did Bronze Age Corsica participate in large Mediterranean trade systems far earlier than previously believed? Could specialized metalworking and military technologies have spread through forgotten seafaring networks? The Mediterranean during the Bronze Age was already surprisingly interconnected. Tin for bronze production traveled thousands of kilometers across Europe and the Near East. Obsidian trade routes existed long before formal empires emerged. If maritime exchange networks reached Corsica earlier than expected, Cauria may represent evidence of a hidden technological crossroads rather than an isolated tribal society. Excavations at Rinarju uncovered evidence of violent destruction. Arrowheads, burnt material, defensive walls, and signs of organized conflict dating to the late Bronze Age. But the scale of the fortifications shocked archaeologists. Some walls use sophisticated dry stone engineering techniques without mortar, relying entirely on weight distribution and stone placement. Several surviving sections remained structurally stable after thousands of years of erosion and seasonal climate changes. This engineering method resembles later polygonal stone systems seen in parts of ancient Greece and pre-Roman Italy. Yet Cauria predates many of those structures. The discovery suggests the inhabitants were not merely ritual monument builders. They also understood military defense, territorial control, and organized construction planning. Such complexity challenges the long-standing assumption that Corsica's prehistoric populations were socially simple and technologically limited. Like many megalithic sites, Cauria may contain astronomical alignments. Several rows of standing stones appear oriented along east-west axes associated with solar movement during equinoxes and solstices. While not as mathematically refined as Stonehenge, statistical analyses suggest the alignments are unlikely to be completely random. Researchers have proposed that the site functioned partly as a ritual calendar, allowing ancient communities to track seasonal cycles important for agriculture and ceremonial events. This possibility dramatically changes how historians interpret Bronze Age Corsica. Accurate solar observation requires long-term sky monitoring, geometric planning, and intergenerational knowledge transfer. The same pattern appears across the ancient world, from Newgrange to Chaco Canyon in North America, where supposedly primitive societies repeatedly demonstrated unexpected, astronomical sophistication. Cauria may represent another lost chapter in humanity's early scientific development. The most frightening thing about Cauria is not what was discovered but what disappeared. No written records explain who built the stone monuments, how knowledge was passed down, or why the culture vanished from history. Its disappearance closely matches the Bronze Age collapse around 1200 BCE, when many Mediterranean societies suddenly fell apart. Some researchers believe Cauria may be the remains of a forgotten transitional civilization. Do you think Cauria was built by a forgotten civilization far more advanced than historians believe? Or are we still missing a crucial piece of the puzzle? Share your thoughts in the comments below.